15.
It is better we start because our timeline should be quite.
Agree, sir. They're just starting to join. Maybe we can start, sir. TV, sir, I request kindly to start with the welcome speech, please.
Maybe we can start with the introduction and all that.
Yeah.
Good morning to all of you. I'm audible now?
Yeah.
Okay, good morning.
Sir, you're audible, but we can't see you.
Your video is not there coming.
Yeah, now it's there.
Professor, good morning, Professor Santha Kumar, sir. Good morning.
Good morning, sir.
I'm your student. I was your student.
Oh, thank you.
One student is there forever. So.
Yes. 20 years back, I was your student in 1997 in CEG.
I remember you very well coming and seeing me inside Strength of Materials Laboratory.
Yes, sir. Very much. Thank you, sir. Thank you for your guidance.
Sir, we are working together on corrosion projects now.
Very good.
And Haji has started a center for corrosion.
Okay.
It was about to get inaugurated, but the COVID came in between.
I feel very fortunate to share this platform with the professor and other eminent peoples and my dear friend, Dr. Radhakrishna.
We should thank iSteel for that.
Yes, sir.
Sir, always pleasure, sir.
Sir, what is the type of audience today? Subramani, sir?
Most of them are site supervisors and field engineers.
Okay.
So I would request you to tailor your lecture, catering to their needs.
Yeah.
Let us not go a little bit high fly. Yeah, you can make it simple. That's what I told Dr. Haji also. Because the ultimate aim of this webinar is that they will have to understand what we are talking.
Yes.
So that is most important. So to that extent, I think you can simplify your lecture.
Yeah, sure.
Okay.
Yes, sir, will do.
Shall we start?
Yes, sir.
We'll go to their level and then talk in a very simple manner.
Yes.
And we can share the PowerPoints if you do. I will send my PPT to you by email. If you want, you can share it.
That is what we are going to.
Yeah.
Sir, actually, Radhakrishna sir, I can make you a co-host so that you can directly share it from your phone.
No. I'm saying to the participants, we can send a PDF file of the presentations.
Sure, sir. We can do this. We can do that.
Because they will that way.
Sure, sir. We can do that.
Like you can even make it like 2 slides per page.
Okay.
So it's easy if they want to print it or whatever. It's easy. Instead of big thing, just 2 slides per page, we can make handouts. And you know how to do that. Otherwise, I can explain later.
No problem. We know, sir. We have an agency. We can who can work on that.
It's just very simple. Just click on handouts and make 2 slides per page. That's it.
Sure, sir.
Okay, sir. We can do it.
That way they'll appreciate, and next program also they'll come.
Yeah.
Okay, sir. We will.
Satish, can we
start? Yes, sir. Please start.
Can we call this as IIT Chennai Center lecture or something?
Sir, actually, we mentioned in the webinar invite as it's ISIL webinar.
You put ICI lecture. That's why I just saw it. Process. Can we call it ICI program or how is it?
I don't know because it was done by iSteel. I don't know what.
iSteel.
Yeah. So
actually,
can we put in association
by
with
iSteel only.
Or no? It's up your call.
Yeah, it is our call, sir.
Yeah.
Okay. Satish, shall we start?
Yes, sir. Please, sir. Go ahead, sir.
A very good morning to all of you.
Morning, sir.
Is it broadcasting now? Yeah.
Yeah, I'm making my speech, welcome speech. How many people are there, Satish?
Sir, almost about 20, sir.
Hello.
Sir, about 20.
Are you able to hear me, Satish?
Yes, sir, we can hear you, sir.
Okay, how many people are there?
Sir, about 20.
20 people, sir.
20.
Okay, we can start.
Yes, sir.
So, very good morning to all of you. I take immense pleasure in welcoming you all, both the speakers as well as the participants, to this webinar on the topic, I myself have forgotten. What is the topic?
Sir, engineering for a new world.
To this webinar on engineering for a new world,
Yeah.
organized by iSteel Management, a reputed TMT rebar manufacturing company in the South. The objective of the seminar is to address and educate on the needs and requirements of the site supervisors and field engineers at site to ensure quality with regard to concrete detailing. The topics chosen for this webinar also tailored around that. The speakers are eminent professors from IIT and Anna University and Abdur Rahman Crescent Institute of Science and Technology, with years of experience in their chosen area of work. They will be sharing their experience and knowledge in the next 4 hours, so that it is hoped that at the end of the webinar, you will all be enriched with sufficient knowledge and understanding as to the codes and practices being followed in construction, quality requirements in construction, as well as best practices in construction to enable you to handle all your issues and problems at site with confidence and aplomb. The session is divided into 2 parts. The first 45 minutes will be used for presentation and the next 15 minutes for question answer session. The questions may be addressed in the following 3 ways. Either you can directly raise your hands and address the question to the speaker and get your answer, or you may send your questions via chat window and it will be answered. Or the third option is you may send your questions to our email ID. We will send it to the respective speakers and get their answers, and we will relay back to them. My one humble request to all the participants is that you closely follow these lectures and derive immense benefit out of it. Since it is a webinar, I would request you to mute your audio and video for better listening. With these few words of introduction, let me now invite Dr. Santha Kumar, past Professor Emeritus, IIT Madras, to make his presentation on properties and behavior of materials used for construction. Dr. Santha Kumar, please.
Thank you very much, and a very good morning to all. It is indeed my pleasure to make the first presentation in this series, and the topic on which I am going to talk is properties and behavior of building materials, especially the materials that are used for construction at site in Chennai, in South India, as well as in various states of our country. I have made this presentation in such a manner that we address mostly field issues and putting emphasis on rebar, quality for rebars, and specifications for rebars, etc. So we will directly go into the slides. Now, if you see the materials that we use for construction is given in this table, starting from clay bricks, timber, structural steel, cast iron, high strength steel, aluminum alloy. These are fundamental materials, and I have given all the properties in this table. If you look at the properties, the structural steel density is 7,850 kg per meter cube, whereas the density of brick is around 1,400 to 2,000 kg per meter cube. Another important property is Young's modulus. Young's modulus determines how the material behaves. And another important property is strength. These are fundamental materials, but as you know, the most favored material for construction now is reinforced concrete, which has two components, namely concrete on one side and reinforcement to strengthen the concrete. We will see the properties of this material. Here, I have given the properties of concrete. The concrete that we have been manufacturing some years ago is M20, but nowadays we have gone for high strength concrete, which we also say high performance concrete. So we are able to manufacture now in India concrete with M20 to M100. And as you know, one of the things with concrete is it is very strong in compression. If you take M20 to M100, the compressive strength is 20 to 100, whereas the tensile strength is very low. Therefore, concrete cannot be used as plain concrete in our structures. It has to be used as reinforced concrete. And when we use it as reinforced concrete, wherever tension occurs, steel is buried to take care of this tension. Some of the important properties of this concrete I have given, namely the Young's modulus, the Poisson's ratio, and fracture toughness. If you look at other materials which are used, not so much for building, but other areas, glass fiber composite, carbon fiber composite, and epoxy resin. Some of these glass fiber composite and carbon fiber composite are used for repair and rehabilitation of structures. When the structures get damaged either due to environmental issues or due to overloading. I'm not going to deal with the uncommon materials like glass, rubber, which are used here and there. I'm mainly going to deal with two issues. One, concrete on one side, M20 to M100, and on the other side, the steel reinforcement, its properties, etc. Before we go into the actual strengths and weaknesses of concrete as well as reinforcement, it is better to know how the concrete or the steel reinforcement behaves under loading. The best form is to draw the stress versus strain curve, which I have drawn here in order to characterize the material. Normally, if you see, the material can be characterized as either elastic, which shows stress is linearly proportional to strain. Such a material we call it as elastic. And if the strain increases without any increase in stress, we call that material elastic plastic. The real material behave differently. They either strain harden or they strain soften. After reaching the ultimate load, if you look at a concrete specimen, the load decreases with increasing strain, which is called strain softening. Whereas if you look at steel, after you reach the yield point, exhaust the yield plateau, the steel starts strain hardening. With strain, your stress increases. So these are fundamental behavior of the material. When you look at this fundamental behavior, we should also classify what is brittle and what is ductile. If the material behaves on reaching the yield point, suddenly fails without showing any increase in deformation or strain, we call that material brittle. So a brittle material is this one. A ductile material is this one. Real materials can neither be completely brittle nor be completely ductile. It is either strain hardening or strain softening. And because of this, we have to be careful, because we in structures do not want to have a sudden brittle failure, and therefore it becomes our duty to see how we will be able to make our structure ductile so that there is ample warning before failure. Now I have shown here a behavior of two materials, one a ductile material and another a brittle material. The green area shows the elastic region. The blue area shows strain hardening region. And after strain hardens, this area of the specimen becomes less and neck formation happens in the steel rod. And due to necking, I have shown the energy that gets absorbed in the red color. What matters to us is not the red area, but is the green and blue area. Green area is the elastic region. Blue area is the strain hardening region. Whatever additional toughness we get between U and F is not useful for the structure. Therefore, the steel reinforcement itself, when we are classifying, when I come to the classification of steel reinforcement, I will come to this. We have to recognize that we are dealing with a material which is ductile, and in ductility, the quantification of ductility also becomes important. Now, this shows a typical stress strain curve of a steel rod in which the load has been increased from zero load till the rod fractures. In this picture, you can very clearly see the elastic region, which is shown in red, then yielding region, which is shown in orange color, and strain hardening region, which is shown in yellow, and finally necking. This is a typical stress strain curve for a steel bar tested in the laboratory. You should remember this curve, because when we are having practical reinforcements, we should see in which range of behavior we are addressing and how we are able to address that range of behavior by classification of reinforcement themselves. I told you that we are going to talk about both concrete as well as steel. So far, we looked at the behavior of steel under tension. If you look at behavior of concrete, we have two different types of behavior, one in compression and another in tension. This curve shows the ascending portion up to the peak compressive stress, and this shows the strain softening portion I have given here a softening, which is also termed as a falling branch of the stress strain curve. The initial tangent modulus of concrete is this one, and the tangent modulus at any other stress level is less than the initial tangent modulus. And as you can see, the behavior in compression of a concrete is completely different from the behavior of concrete in tension. You have a very small tensile behavior, which we usually neglect in design. And because concrete is strong in compression, we use concrete in compression, and we provide steel to take care of tension where concrete is weak. We saw concrete can have a range of M20 to M100. The stress strain curve of various strengths of concrete are different. High strength concrete is brittle. You can see very high strength concrete. You go from zero load up to the ultimate load, and there is a sudden failure. You don't have any ductility at all in the case of a very high strength concrete. Whereas if you take a low strength concrete, M20, that is the stress strain curve, you can see the maximum stress is reached at 0.002. And you have, though theoretically we recognize the strain up to 0.0035, we have the strain can go even up to 0.01. Therefore, a low strength concrete is ductile. Yeah, high strength concrete is brittle. So if you are using high strength concrete, it becomes necessary for us to introduce steel to take care of ductility, even in the compression side. So this is to be recognized. And normally it is preferable to use high strength concrete with low water cement ratio, because we get a dense, good quality concrete which naturally protects your steel also against corrosion. Now let us go to the actual rebars that are available in the market and how these different types of steel are used for different types of structures. Use of high strength deformed steel bars for concrete reinforcement is codified in IS 1786-2008. The strength grades that are available are Fe 415. 415 means 415 Newton per millimeter square is the strength of that bar. Fe 415, Fe 500, 550 and 600. There are 4 strength grades that are available, and in each strength grade, varieties of steel are available. 415, 450D, 415S. This D bar is a ductile bar which has got special requirements with respect to ductility. And S bar is a seismic resistant bar, which is having additional requirement compared to D bars. So D bar is a ductile bar, S bar is a seismic bar. Both these bars have been newly introduced. We have been traditionally using Fe 415. Today, it is more advantageous to use Fe 500, Fe 500D and Fe 500S. In addition, we have Fe 550 and Fe 550D. Not many manufacturers manufacture Fe 550 and Fe 550D. But let me tell you, it is advantageous to use Fe 550D because, especially in columns, your congestion of steel can be significantly reduced if you are using Fe 550D. In addition, for very special structures, we can also use Fe 600. We will see some of the structures where very high strength bars have been used with advantage. This is a high performance steel. A bridge in Tennessee is a 2-span continuous structure on the straight route 53 over Martin Creek in Jackson County. 25% of reduction in weight was achieved and 16% reduction in cost was achieved because high performance steel was used, that is 600 and above. What are the advantages you got because you used high performance steel? The span was more. Because the span was more, the work need not be done in water. The columns can be erected on the shore on either side. That is a very big advantage. Therefore, such advantages can be had if you go for high performance steel. Today, we are not using high performance steel. We are using ordinary steel with maximum 550 or 600. High performance steel has got steel even up to 700, 750, etc. And not only that, they are built in with corrosion resistance, which they call weathering steel. Such steels we are not manufacturing in our country, but mostly we are depending on concrete to protect our steel against corrosion. The convention that we follow for the grade is 2% proof stress or yield stress in Newton per millimeter square. So if I say FP 500, it is 500 Newton per millimeter square. D denotes categories with same minimum 2% proof stress, yield stress, and enhanced specified elongation and ultimate strength requirements. So two requirements are additional for D: enhanced specified elongation and ultimate strength requirement. We will see what this enhanced specified elongation. This is applicable to hot rolled steel without subsequent treatment, with controlled cooling and tempering, that is your TMT bars, cold work steel, that is CTD bars. We are not now using CTD bars because there are several disadvantages of using CTD bars. We have moved on from CTD bars to hot rolled steel. We have to move from hot rolled steel to alloy steel. We are not manufacturing many types of alloy steel as yet. Whereas high performance steel, they use alloy steel. Inclusion, the standard is applicable to corrosion resistant steel. It is applicable to corrosion protected steel. There is a slight difference between corrosion resistant steel and corrosion protected steel. Corrosion protected steel is a steel rod, ordinary rod, coated with some coating which will prevent ingress of moisture and protect your steel. One of the main type of coating that is used is fusion bonded epoxy coating. Whereas corrosion resistant steel is change in the chemical composition so that you add certain elements which gives additional time for corrosion to set in. You cannot say they are corrosion
resistant.
No corrosion can occur. The time required to corrosion to set in is more in corrosion resistant steel. What are the various nominal diameter that is available in the market? I have divided it into three categories: small bars, medium bars, large bars. Why we have divided like small, medium, and large? Medium is the one which is moving and is used extensively. Large bars are used in multi-story buildings and bridges. You have to remember one thing. You cannot have steel reinforcement exactly tailor-made to your structure. If your structure column is 3 meter, 3 meter, you cannot manufacture steel for exactly what you require. You manufacture steel and then cut it, lap it, and use it. When you are lapping, there are some disadvantages. One, there is wastage of steel, and C, you should know where to lap and where not to lap. And here, the small, medium, and large, we divided into three categories in order to say that you cannot lap certain bars. Large bars cannot be lapped. Large bars have to be used by using special connectors. Therefore, small bars you can lap, medium bars you can lap, but large bars you cannot lap. Similarly, you should know when you are welding whether your steel is weldable. The nominal mass is given here. The mass is based on density, and the areas, there are 13 sizes that are recognized in IS code, and the gross sectional area is calculated based on mass. We take 1 meter length of rod and then weigh it, and from the weight we work back and calculate the sectional area. The sectional area is a very important issue in the field. Therefore, mass weight determined to a precision of plus or minus 0.5 in kg, and length to be determined plus or minus 0.5% in meter. These regulations are given in the code. Yes. Therefore, if I say 10 mm diameter bar, in reality it will not be 10 mm. If you introduce these tolerances, it will be 10 mm plus or minus something. That plus or minus is based on actual test that you conduct in the field. I have given an example of how what is the accuracy for which your scale, weighing scale has to be. If you work back based on given tolerance in the code, you will find that approximately 1 gram or 0.001 kg is the accuracy for which you have to work out in order to get the correct diameter. Therefore, it is not correct to use ordinary balance in the field. You will have to use an electronic balance which will have capability to measure at least to an accuracy of 1 gram. Then only you can correctly determine whether a bar is within the code prescribed limit with respect to its diameter. Precision in length. Length precision is not that important, works out to approximately 2.5 mm. Any ordinary scale can be used for length, but you have to use an electronic balance to calculate, to measure the weight. I have here shown if the length is specified, tolerance limit that you have to check in the field, minus 50 plus 75, if the length is specified. If minimum length is specified, it is minus 0 plus 50. The chemical composition is important. Permissible chemical composition with respect to carbon, sulfur, phosphorus. Sulfur and phosphorus are given. This gives you the limits, percentage maximum of various chemical composition. You can see there is a difference between D bar chemical composition and ordinary bar chemical composition. For instance, if you take carbon, Fe500 0.3%, Fe500D is 0.25. So carbon is limited more stringently in Fe500D. This is to what accuracy you will have to measure the various percentages: carbon, sulfur, phosphorus, sulfur and phosphorus. Bond strength is one important parameter. Bond strength of plain round bar, bond strength of deformed bar are measured at two different slip levels, one 0.025 mm and another 0.25 mm. Bond strength at a slip of 0.025 mm of deformed bar should be larger than 1.4 times bond strength of plain round bar at a slip of 0.025. 0.025 slip is for serviceability limit and 0.25 mm slip is for limit state of collapse. Bond strength at a slip of 0.25 mm of deformed bar should be larger than 1.8 times the bond strength of plain round bar at a slip of 0.25 mm. So these are conditions which has to be satisfied if we have to approve the deformed bar, especially with respect to the deformations that are put on the bar, because These deformations affect the bond strength of the bar when pull-out test is conducted. Physical properties. One of the most important physical properties is proof stress. Another important physical property is total elongation at maximum force. Now, total elongation of fracture is different from total elongation at maximum force. We will see that. 0.2% proof stress, the stress at which non-proportional elongation is 0.2% of the original. I'll show you in a curve. That will be very good. Here, this is the stress strain curve, and in the stress strain curve, I have shown what is 0.2% offset proof stress. I have also shown what is the tensile strength, and I have also shown what is the fracture stress. This is the fracture stress. This is the maximum. This is the 0.2%. These three are important salient points in a stress strain curve. Elongation is measured as delta L by L naught, and the percentage reduction in area is also measured, which will give you how much necking takes place. One thing I would like to tell you is not only loading curve is important, unloading curve is also important. Unloading curve, I have shown here the loading curve, strain hardening, then unloading, then reloading. If we reload, the reloading curve has to follow the unloading curve. Now there is something happening for the crystal structure of the steel. When you reach the yield, you can see during elastic, the crystal structure is uniform, and during elastic plastic, crystal structure modifies itself with the inclined line formation. These lines were first detected by one Lueder, and hence these lines are known as Lueder's lines, and these Lueder's lines determine your strain hardening behavior of the structure. When I remove the load, the Lueder's line stays, and when I reload it, again the slip occurs along the Lueder's line. That is what is shown in this figure. One other important property is toughness. Here I have got three different materials. One is ceramic, the second is metal, the third one is polymer. The area under the stress strain curve is called the toughness. And you can see the toughness is high for metals. It is very small for unreinforced polymers. It is small for ceramics. So we need to have good toughness, which will avoid brittle failure. And during earthquake, sufficient amount of energy can get absorbed because of toughness. Now here I have shown brittle material and ductile material. Brittle material are A and B, ductile material are C and D, and approximately I have given here percentages when you can call it as a brittle or ductile. Now coming to how this is applicable to our steel, we said that we have two special steels, D bars as well as S bars. This table is extracted from IS 1786, and watch the difference in specification for FE 500D and FE 500S and FE 500. For FE 500, there is no specified percentage elongation at maximum stress level. For 500D, it is 5% at maximum stress level. At 500S, it is 8%. Therefore, significantly better behavior of S bar compared to D bar, and significantly better behavior of D bar compared to ordinary Fe500. This is one aspect. The second aspect that you have to look at is total elongation. Total elongation is at fracture. Only total elongation is specified for Fe500, which is 12%. There is no meaning in specifying total elongation because what is useful to us is only up to maximum stress level. And that is why rightly 500D and 500S specifies limits on ductility based on maximum stress level and not based on the total fracture level. The second important aspect you should know is TS to YS ratio. TS is tensile strength, YS is yield strength. The TS to YS ratio is 1.0. If we say 500, 500D and 500S, it is 1.08 for 500, 1.1 for 500D, and it is 1.25 for 500S. Now, you can realize that the stringency of going exactly the percentage is adhered to in Fe500S, which means inadvertent overstrength will not occur in your structure. Whereas in Fe500D and Fe500, because maximum limit has not been capped, inadvertent overstrength can occur. That means your beam may become stronger than your column. To avoid that, these provisions have been given, and therefore the S bar is superior to D bar and D bar is superior to ordinary Fe500. Of course, this is bend test. Mandrel diameter as given in the table. We have to do a new bend and check whether there is any cracking. If there is no cracking, we can permit it. The rebend test. The test piece bent to an inclined angle of 135 degrees. Mandrel diameter as specified. The bent piece should be aged for 30 minutes in boiling water. Piece should be bent back to 157.5 degrees. This is how it is done to see whether bend test and rebend test is getting passed. This is the figure for rebend test. Retest. This is some, if there is some dispute how you can, how many tests you have to do, etc., are covered in the specification. Now, coming to concrete, now we have seen some properties of steel. Now, let us go to concrete. In the field, even today, many people use what is known as a nominal mix. Nominal mix is 1, 1.5, 3, 1, 2, 4, etc. Nominal mix proportion, arbitrarily fixed based on volume ratio, have no significance in modern concrete technology. If you use ordinary mix 1, 2, 4 or 1, 1.5, 3, you can never tell what is the strength, what is the durability of that concrete, because everything is uncertain. Correct proportion should be controlled in the batching process on the basis of weight. Even if it is a very small work, weigh batching is to be adopted. Now, how do we design concrete? For two criteria, we design concrete. For durability, one requires larger water cement ratio. However, this affects the strength and durability. Properly proportioned concrete mix for a certain requirements of compactability, strength and durability should have minimum possible cement content to make the mix most economical. On one side, you will have to look at economy. On the other side, you will have to look at workability. On the third side, you have to look at durability. So if all the three have to be satisfied, you will have to have a specified water cement ratio and a specified workability apparatus at the site to check whether compaction is satisfactory. The specified workability apparatus is nothing but a slump cone, which I don't see in any place. And if you see if you ask them what is the workability, they will not be able to tell. So new materials have been recognized way back in 2000 in IS 456 2000, fly ash, silica fume, rice ash, metakaolin, blast furnace slag, and super plasticizers. These are additives to concrete. And to make your structure proof against corrosion, you have to take every precaution. The cover concrete becomes very, very important. Cover blocks have to be used both for horizontal members as well as for vertical members. For vertical members, such special types of cover blocks can be used, or you can make your own cover block at the site with a circular block with a hole at the middle. These are tables extracted from IS 456 2000, which gives you the minimum grade, the maximum water cement ratio, and minimum cement content. These have to be followed very, very stringently. This will not give you the best results, but this will give you acceptable results. If you want best results, you will have to go much better than what is specified in IS 456 2000. This is a scanning electron microscope of a concrete specimen. No load has been applied. I took a slice, put it under a scanning electron microscope. The figure I got is this one. You can see the aggregate. You can see this is the aggregate. This is the mortar, and you can see the cracks in the mortar. These cracks occur because of shrinkage. This cannot be avoided. Therefore, you can never say your concrete is crack free. Your concrete is fully with cracks. You have to live with cracks. If you have to live with cracks, you should know what to do. You have to protect your steel, especially. Or the crack width will have to be minimum, which will not permit water. Now we have built excellent structures with new materials. I have given here the future which we can think of in the field: high performance concrete, high strength concrete, smart concrete, self-compacting concrete, super cover concrete, fiber reinforced concrete, slurry infiltrated fiber concrete, lightweight concrete, colloidal concrete, reactor powder concrete. All these have been used world over in some special structures, but they have not come in a very big way, excepting high performance and high strength concrete. Other concretes have been used here and there. But it is good to know that these varieties of concrete are now available for the field engineers. This is a work which we did some time back. This is JJ Hospital flyover. What type of material that we used, I thought I will just post to you. Cement, 53 grade, microsilica, super plasticizer, water cement ratio. We did the mixed design. The big mixed design was tested. The cube strength at 3 days, we got 59 MPa. Cube strength at 7 days, we got 74 MPa. Cube strength at 28 days, we got 87 MPa. And you can also see the cross section of the bridge, which is something similar to fish belly. This cross section was chosen in order to minimize wind load effects on the structure, and it has been successfully completed and used with a in India, and we used a concrete strength of 87 MPa. Thank you very much. I tried to give you an overview of the concrete aspects as well as steel as used in the field. Thank you very much.
Sir, thanks a lot, sir. It's a wonderful session. Santha Kumar, can you hear me?
Yeah.
Okay, sir. Thanks a lot, sir. It's a wonderful session. We've been blessed to hear it from you. Yes, sir.
Santha Kumar, for your intensive and exhaustive presentation. Now I will request questions from our participants. Oh,
Sir, I'm just looking at
there
it,
is
sir.
a question from
The
TV, sir,
questions
is
can,
typing it.
if you can tell me the questions, or they can send the questions by chat box.
That's what I'm saying, sir.
that's why. So if they can send it by chat window, okay, or by mail, okay. If they are not willing to ask directly, then we can proceed with the next lecture.
Yeah, I'm just waiting, sir. I think let's give some time for the attendees to see if they have any questions to ask.
How many people are
TV,
there now?
so about 35, sir. So Mr. Senthil, sir, is set to join us, I think.
No, that's why I have to go to him.
Okay.
So that is why this period we can use for question answers.
Okay, sir.
How much time we have?
Once again,
sir, we have got, we still have time, sir. We have 10 more minutes.
Another 10 minutes.
Santha Kumar, sir, there is a question from Satish Kumar. He is asking about, can you explain a little about fracture toughness?
Okay. Okay. There are three different materials we discussed. One is a brittle material, ductile material, and real materials. If you see, there are two issues in each curve. One is the stress and another is a strain. So with respect to energy absorption, if you want to know, it is best to calculate the toughness. Toughness is calculated as the area under the stress strain curve. Suppose I take this area under the stress strain curve for a brittle material is this one. That is the toughness of a brittle material. Suppose I have an elastoplastic material, the toughness of an elastoplastic material is this area, which is some 10 times the toughness of a brittle material. So it will be able to absorb 10 times the energy. That is why during an earthquake, I should not use a brittle material which does not have any earthquake resistance and it will collapse. Whereas if I use an elastoplastic material, I have 10 times the toughness of a brittle material. Therefore, even if there is a large input energy beyond what I have calculated as per my calculation, the structure will not collapse. The structure will survive such an earthquake. That is the real meaning of calculating fracture toughness. And because of that, we will be able to quantify how much a particular material is better than the other.
I think Satish Kumar would have got his answer.
There is one more question from Vishnu Mohan.
Yes, sir. There is one more question before Vishnu Mohan. It is, can you please explain about viscoelastic material?
Yeah. See, rubber is a viscoelastic material. In the viscoelastic material, the deformations are quite large. Therefore, we cannot use viscoelastic materials in our structures. It has got, for instance, a membrane or a plastic rubber sheet. It's a viscoelastic material. I cannot use it in a structure because I need in the structure stability. Viscoelastic materials will not have local stability.
Thank you, sir. That's one more question from.
Satisfied with the answer?
Sorry, sir.
Yes.
So one question from Mr. Vishnu Mohan.
Hello.
Yes.
There is one more question from Ilango.
Yeah.
TV sir, I think I would suggest let's go one by one. We'll start with Vishnu Menon. His question is about
No, that he answered, no?
no, he's making own cover blocks with respect to grade of concrete.
Yeah.
Yeah, see, the cover block should be of the quality of cover block should match with the quality of concrete specified, and there should not be any possibility of leakage path between the cover block and the surrounding concrete. If the grade of concrete you are using is M40, the cover block should have a grade of M40 or higher, not lower.
Okay, so there's one more question from Satish Kumar. It's about seismic bars. Kindly explain about seismic bars.
Yeah, the seismic bar, yes, has been introduced recently. It is better than the D bar. It has got better ductility. It has got better quality with respect to specified tensile strength.
Okay, Mr. Ilango has asked about how to check internal micro cracks in concrete.
How to?
Check internal micro cracks in concrete.
Yeah.
Concrete.
Yeah. The extent of cracking and voids can be checked by chloride penetration test. There is a test apparatus, rapid chloride penetration test. We can do it, and that will give us an indication of internal cracking as well as internal voids.
Okay, sir. And another question is from Purushothaman. Can you explain new concrete material, Sifcon?
Sifcon.
Yes, sir.
Yeah.
New concrete material, Sifcon.
Yeah, yes. I have listed
Yeah, you have listed it.
Sifcon. This is slurry infiltrated fiber concrete. Now, normally the percentage of fibers in a fiber reinforced concrete will be around 1 to 1.5%. But if you want very high percentage of fibers, say 20%, it will be difficult for concreting. The fibers will get together. A phenomenon known as balling occurs, which will introduce new voids. So to avoid this, the methodology for construction of Sifcon is changed. You take a mold, and in that mold, you first pack the fibers. And after packing the fibers, infiltrate the concrete slurry, so that the slurry goes and fills all the voids. That is slurry infiltrated concrete. This is used extensively in small fiber reinforced concrete boxes. Especially, I am told that the slurry infiltrated concrete funeral boxes is very famous in United States, because if they use very costly wooden boxes, these wooden boxes are stolen away, whereas these slurry infiltrated coffins cannot be stolen away. That is one application for which the slurry infiltrated fiber concrete is used.
Okay, so there's one more question from Mr. Ramesh Kannan. He want to know, sir, could you please explain about the grade designation of ultra high strength concrete in Indian and international perspective?
Pardon? I'm not.
Sir, can you please explain about the grade designation of ultra high strength concrete in Indian and international perspective, Codal perspective?
Okay. Now, actually, we have not got specifications in IS 456-2000 beyond 40 or 50, and our stress strain curve itself will change. I showed you the ultra high strength concrete as a brittle fracture. Therefore, the Eurocode as well as ACI gives you stress blocks that are to be used for high strength and ultra high strength concrete. But even if the stress blocks are given, if you are using high strength or ultra high strength concrete, you should know that the ductility will be less, and you should make good the ductility by steel reinforcement, even in compression.
Okay, sir. There's one more question, sir. There's one more question, sir. Which alkali activator is best for fly ash based geopolymer? Sodium silicate or potassium silicate?
What's the question?
Which alkali activator is the best for fly ash based geopolymer? Is it sodium silicate or potassium silicate?
Sodium silicate is better. Potassium silicate also can be used, but sodium silicate will give you faster results.
Okay, so I think they have got their answers. Attendees, is there any other questions, or we can move on to the next session?
I see, Rijay. I think we can go to the next session, I think.
Yes, sir. I think we are almost there.
Okay.
Yes, sir. We are almost past 10.
Okay.
Dr. Senthil has joined.
I see you joined. Oh, that's what I'm asking.
No, not it, sir. Not it.
Not yet, eh?
Not it, sir.
Can you just give a call and find out?
Yes, sir. Maybe if you can mute your video, audio, and take a call.
Please give a call, eh?
You're calling him, sir? I don't have his number.
Vinky? You are? Ah, no, they are not coming. ஒரு கால் பண்ணணும் எப்படி பண்ணலாம் அவரு இன்னொருத்தர் வரவே இல்லையா லெக்சரர் அவரோட நம்பர் இல்லை என்கிட்ட எப்படி எடுக்கிறது
வேற என்ன சர்ச் ஹியர் நோ
75986 32796
ரீசார்ஜ் ஆப்ஷன் பெறுவதற்கு ஏதாவது ஒரு கீயை பிரஸ் பண்ணுங்க.
Hello, Dr. Senthil, are you joining?
Sir, எனக்கு இது வரலைங்க சார். இன்னும் இது வரலையா? கம்யூனிகேஷன் வரலையா?
இது கம்யூனிகேஷன் நேத்து லிங்க் வரலையா? இருங்க 1 minute அப்படியே இருங்க.
Sir, can you just confirm his email ID, sir? It's senthil@annauniversity.in, right? .edu.
ஹலோ
யூஸ் பண்ணியா?
ஹலோ
ஹலோ
வந்துதா சார்?
இல்லைங்க சார், வரலைங்க சார். எதுல? ஜிமெயில தான் அனுப்புறாங்க.
இல்லை ஜிமெயில் சார், உங்களுக்கு என்ன நீங்கள் இமெயில் கொடுத்தீங்களோ அதில் தான் பண்ணியிருக்கோம் நாங்கள்.
இல்லையே, இப்ப நான் அந்த அது இமெயில தானே இருக்கேன் இப்ப.
Sir, can you just ask him to confirm the email ID, sir?
Sir, can you just give me your email ID? I will tell him.
senthilr68@gmail.com.
senthilr68@gmail.com.
68@gmail.com.
senthilr68@gmail.com pa.
Senthil_r68, sir. Senthil_r68@gmail.com. Okay, sir. I'm just sending it right away.
Okay, okay.
Okay, sir.
Sir, இப்போ அனுப்புகிறோம் நாங்கள், நீங்கள் உடனே ஜாயின் பண்ணுங்க. ஓகே
Okay, sir.
ஓகே ஓகே
I am ready only.
ஓகே ஓகே.
Sir, அவருக்கு we should have got the panelist.
இதில் வருவார்.
அங்க மியூட் பண்ணா நீ பேச முடியாது டேடி. பேசுற நான் அனுப்பணுமா நீ அனுப்பிக்கிறல?
ஹலோ அனுப்புறீங்களா?
I'm just sending it, sir. Just 2 minutes.
ஆ Very nice, sir. Your lecture.
I hope I have maintained the timeline.
Yes, yes.
You're always perfect, sir.
Huh?
You're always perfect, Santha Kumar, sir.
Oh, no. Now, போயிடுதாப்பா அவருக்கு?
போயிடுச்சு, sir.
Okay, he will join any time. Let us see.
We would have got it from Zoom.
Actually, I got from 2 places, one from your side and another from
Yes, sir.
Zoom.
Zoom automatically sends it if you're added as a panelist, sir. So we should have got it from Zoom, sir.
வந்துச்சா சார்? ஜாயின் பண்றீங்களா? ரைட், ஓகே. அவருக்கு வந்துட்டாம்பா, ஜாயின் பண்றேன்னாரு.
ஓகே சார், ஓகே. Santha Kumar sir, a lot of people are sharing, they're sharing their thank you with you. Like there are a lot of people are sharing their thanks with you.
Okay.
Our GM, Mr. Chandrasekharan sir from factory has said thank you to you.
Oh, thank you.
Mr. Rajeshwaran Civil, Sedu Institute of Technology, I just shared his thank you note with you.
Okay.
And Mr. Muttalagan has shared his thank you note. And especially Dr. Ramesh Khanna, who asked multiple questions today. He's great in learning from you.
And also you can share my PPT to whomever who wants it.
Yes, sir. Yes, sir. You can mail it to me, sir. Later on, I'll share it with all the attendees.
Yeah.
Senthil sir, very good morning. Dr. Senthil has joined.
Good morning, sir. Good morning,
Good morning,
Professor.
doctor.
Good morning, sir.
Good morning. How are you? Can we start?
Yeah, yes, sir. Yes, sir.
So a few brief introduction.
Good morning, Chandil sir.
Hello.
Good morning. Good morning.
Good morning. So, hello.
Sir. Hello.
Dr. Senthil, your topic for today is Codal requirements.
Okay.
And I hope you will be covering 1786, 456, and 13920.
Yes, sir.
Within the stipulated time available to you.
Okay.
And I would request you to keep the timing so that we are not overrunning. Okay.
Okay. Okay, sir.
Now you can go ahead with your lecture.
Okay.
Thank you.
Yes, sir. I just made a co-host. You can share your screen, sir.
Yeah.
Okay.
Vinge?
Sir, share.
Vinge.
Hello.
Yes, sir. We can hear you, sir.
Yeah, this slides is you are able to see the slides.
Yes, sir. We can see, sir.
Okay. Okay. Good morning. So first of all, I thank the ICL and Professor Santha Kumar sir for giving me this opportunity to share the this lecture on codal requirements on the various codes like IS 456, IS 1786, and IS 13920. So in our country, we are building many structures. We are designing the structures for various codal requirements. We design for gravity load as well as lateral load. But in the nature, again, there are many changes because whatever the earthquake occurred in Gujarat, Bhuj and all, the magnitudes are going to be much more than what is expected. And then again, the code of practice, they are being revised to take care of that part. And then this slide shows the few failure of the structure. Even during the earthquake, the structures completely collapsed because of the one thing is they have not updated the as per the latest codal requirement. The other requirement is the nature of the forces are higher than what is expected. So the designer has to design the structure for the whatever the probable load acting on the particular building system. So in this lecture, I am going to focus on the various codes. For the benefit of the engineers, we know, everyone know IS 456. IS 456, the latest code is the year 2000, but again it's being revised. It is mainly used for design of concrete elements. And similarly, we have a code IS 1786 that is for design of, that is for testing and use of structural steel, that is not structural steel, the reinforcing steel, that is rebars. And again, when we talk about the code IS 13920, this is for the ductile detailing for the reinforced concrete structure subjected to seismic forces. We have other two codes. This is mainly used by the designer, that is IS 1893. So this estimates the earthquake load. And IS 875 is the standard for the general loads. It is talk about the dead load, live load, and wind load and load combination. In addition to these two codes, mostly the designers will follow, there is a code, the design aid, that is SP16, that is design aid for reinforced concrete to IS 456. And there are important codes, SP34, that is a special publication. It is on handbook on concrete reinforcement detailing. So the practicing engineers, normally they should follow the 4 codes basically. One is IS 456, IS 1786, IS 13920, as well as SP 34. Now, in India, mainly we build concrete structures. So in concrete structures, we use normally the materials: cement, sand, coarse aggregate, water, admixture. And then we use reinforcement. So the concrete is called reinforced concrete. So whenever we talk about cement, now as per the current
video வரவே இல்லையே.
Hello? Hello?
Sir, please continue.
Yes.
TV sir, please mute yourself when you are talking outside of the topic, sir.
Yeah, I am always, it is under mute only.
No, we are able to hear you now. Senthil sir, please continue.
Yeah. So the major changes now as per the expected new code, the high strength materials we are going to use in construction. So we are going from M40 grade now to M60. Now it is going up to M100 grade. Now we may say that why M100 grade? Because most of the buildings what now built are high-rise buildings. Now earlier we used to build a very short building, that is ground plus 3 stories or ground plus 5 stories. But nowadays, because of the requirement of the housing, now we go with the very high stories like 13 floors, 15 floors. Even the government department like even slum clearance board, nowadays the slum clearance board and housing board, they build the structure not less than 10 floors. So whenever you are going for a high-rise building, so obviously we have to use for the high-strength material to optimize the structural sizing. So from M40, what we go with up to M100 grade. And then probably you all know that, I think Professor has covered extensively on material part. This fine aggregate, nowadays we are not using the river sand. Now we are using the manufacturing sand. And then how to use the manufacturing sand and how to do the mixed design. Because the code says now, you have to use only the mixed designed concrete, design mixed concrete. You should not use nominal mix. Normally, whenever we talk about the mixes, traditionally we used to follow the nominal mixes. For example, if we say that M20 concrete, we say that it's a nominal mix of 1:1.5:3. But 1 is denotes cement part, and 1.5 is the aggregate, that is coarse fine aggregate, and 3 is the fine aggregate. And then we mix with the water cement ratio of 0.45, etc.
Mute பண்ணி தான் பண்றேன். Mute தானே போட்டுருக்கேல?
No, we can hear whatever you speak.
I see.
You have to mute on the left bottom corner, sir.
Yeah, muted it.
Hello? Yeah.
There will be a red line which come up on the mic.
Yeah.
So nowadays, because of non-availability of the river sand, we use the manufacturing sand. Whenever you use the manufacturing sand, and again the quality of the aggregate, now the code suggests that you have to go with the mixed design. So whenever there is a lot of variation in the material, so to arrive at the proper proportion, we should not use the nominal mixes. Now we have to use only design mixes. And again, when you talk about the reinforcing steel, so we have various grades of steels are available. Sorry, it's a Fe415. It's a typographical error. Fe415 not used nowadays. It's not available in the market. So normally we go with the Fe500, Fe550D, Fe600, and even Fe650 steel is available now in market. Now, how the code classifies the grade of the concrete? Normally, it classified into 3 categories. One is ordinary concrete, another one is standard concrete, the third one is high strength concrete. When you talk about ordinary grade, it varies from M10 to M20. Probably now you know that even ordinary grade M20 comes under ordinary grade concrete only. But most of the structure is being built now using M20 grade only. But whereas the code says that whenever you use the standard grade of concrete, it varies from M25 to M60. Even though the code says M20, for other criteria, it's better when we use the higher grade like M25 and M30. And whenever you talk about the high rise and high building, the high strength classified into the three categories, it varies from M65 to M100 grade concrete. Now, there are now the IS 456 2000 code is being again revised. There are few changes are going to be incorporated in the code. Some of the points I am going to highlighting here. So the code with respect to cement, it says that we can use any type of cement and any grades of cement. So it is OPC, we can use PPC and PSC and are used for general purpose elements. And then for special purposes, you can use other grades, other types of cement. And similarly, we are saying that minimum mineral admixture, there is a limit on the usage is given, like 5S and GGPS for use in RCC. And when you talk about the chemical admixture, there are many more types of are permitted nowadays because in the market, there are other grades of chemical admixtures are available that also we can use it for now in our construction. Now, what is the existing IS 456 2000? And then again, it's a proposed IS 456 code. It is given here. It is still in the draft code. I'm giving the draft code provision. So the code is is going to be revised and then it's given for circulation and it will be adopted in very soon. So the existing code IS 456 2000 talks about all these grades. So these are familiar to us. OPC, rapid hardening Portland cement, Portland slag cement, Portland porcelainic cement, Portland porcelainic cement and calcinated clay base. So all these cements are given. But what the proposed code? The proposed code says that for general purpose, you can use these four cements, OPC, and then slag cement, Portland porcelain cement, and Portland porcelainic cement. You can calculate it by clay base. So you can use for general as well as reinforced and pre-stressed concrete construction. And whereas whenever you are going for special purposes, you can use other type of cement like sulfate resisting cement. So all these things, low heat Portland cement, rapid hardened Portland cement, high alumina cement, so super sulfated cement, white cement, everything you can use it for the other purposes. However, the special purposes you are permitted to use this cement. Now, one of the changes is the Young's modulus of the concrete. Normally, those who are using designer, just I am touching the few design points also here because of the Codal requirement. Normally, use 5000 root FCK for calculating the Young's modulus of the concrete. But now the code is going to change. The Young's modulus of concrete is going to be 10,000 FCK over 4.3. So this is going to become, and then this value is going to be reduced based upon whenever you are using limestone, you are using this Young's modulus for 10%, and whenever you are using sandstone, it is used for 30%. It is mainly for designers to account in the analysis purposes. And similarly, when you talk about the flexural strength of concrete, earlier whatever you used, now the code follows same thing, 0.7 root FCK. And similarly for split tensile test, there is an equation is given. So FCT is going to be 0.5 times of root FCK. So these factors are now it's being revised and then it's going to be adopted in our structural analysis and design. Now probably this M sand, probably professor might have covered extensively on this material. So M sand is now permitted. I'm just touching few points only. So what is going to be here? So this has to be tested in the laboratory as well as in the field. So one of the main problem, there is two different things are there. Okay, what is the two different things is, one is, I will say that it's going to be a M sand and then there is a quarry dust. So both are now mixed there. So that can be, you can say that you can do the sieve analysis and then you can identify and then how these particle sizes. So particle sizes plays a very, very important role. So that has to be done. So for example, some of the tests you can do it in the field also, whether the M sand is mixed with the quarry dust. So that can be identified in the by conducting the field test. And here you can see that the particle sizes compared. So river sand and M sand. So whenever you are saying that this is going to be the cubical shape you have to get in the aggregate particle, that you have to ensure that for getting the good bond and then decide strength. And then whenever you talk about the field test on M sand. So one thing is you do visual observation. So whether it's going to be a cubical size or it's going to be mixed with a dust particle, so that can be taken, and then various things we can look at in the field also. So that is given here. So this is the poor quality, and then good quality is given. Similarly, there are manufacturing types. So there are using VSI cone crushed sand as well as jaw crushed sand. So there are VSI crushed sand will have M sand will have a good quality when compared to the jaw crushed sand. So that is also given here. And when you talk about the chemical admixture, the code permits us to use many chemical admixture. Now what we are going to, new chemical admixtures are going to be introduced are shrinkage reducing admixture, and then corrosion inhibiting admixture, and permeability reducing admixtures also to be used, non-hydrostatic condition, and permeability reducing admixture, hydrostatic condition also used. Whenever you use shrinkage compensating admixture, shall not be used for structural concrete. So these are the chemical admixture. Now the code permits us to use in the construction. Now, when it comes to the reinforcement steel in concrete, again the 415, sorry, it's 450, it's not 450, it's 415. It is not now commercially available in the market. Now we are going to use, we are using now FE 500 grade, and we use FE 550D grade, and FE 600 grade, and FE 650 grade. So FE denotes the iron part, and then the 500, 550 is denotes characteristic yield strength of the steel bar. So whenever we are testing it, we should get the minimum yield strength is 550, or 600 grade means 600. So that is what your characteristic yield strength of the bar. And D is the special bar, which is mainly denotes which have higher ductility. So whenever you design for lateral load like earthquake, and most of the Chennai and Coimbatore, everything comes under zone 3. Whenever you are in the zone 3, so obviously you have to design for seismic loading. Whenever you are going to be used for seismic loading, so obviously whenever you use high-rise building, so obviously we have to use the D bar. That is, we will have a higher ductility bar. So detail I will give in a later part of my lecture. So compared to the 500 grade, what we are going to get, we will get more percentage of elongation we will get in the ductile bar. So it is more ductile. So even what is the use of this ductility? Even the earthquake of the excess magnitude acting on a particular building, the building is permitted to collapse in a ductile manner. So whenever it collapses in a ductile manner, the people can escape from that building, they can save their life. So the main purpose of using ductility, the building is going to fail in a ductile manner. So reinforcing bar is still a ductile bar, but still further ductility, so that what happens, the columns and beam structures are going to bend largely. So whenever it's going to bend largely, so what happens, the people can escape from that building, they can save their life. So it will not collapse in a brittle manner. So brittle collapse is a sudden collapse. Like you take a brick and then you can apply a compressive force, it fails suddenly. So whereas the steel bar, it cannot fail suddenly. So that is the property of the ductility. So it's a much excess ductility is available in D bar. Now, one of the important composition, what we are talking about in the codal provision, the code gives, we have to test the bar for both mechanical properties as well as chemical properties. So chemical composition, now we have to do it in a very in a elaborate manner, and to understand what is the chemical composition. So whenever you talk about the chemical composition, it will help for the durability of your structural system. So the code prescribes the chemical composition limit. For example, one of the important thing is carbon. Now, if you look at carbon, so this Fe 500 grade, so we'll have a carbon limit of 0.3, and Fe 500D grade will have a carbon content limit of 0.25. Even carbon content, even for 500 grade, so it's 0.3. So carbon content is one of the important chemical composition. It will give the strength to the bar. Whenever you go for high strength bar, so the carbon content value is slightly more. So even Fe 500 grade, if you look at the Fe 500 grade, the carbon content is 0.3. for ordinary grade, but the code prescribes that even 500D grade, the carbon content is to be 0.25 only. We have to restrict the carbon content, it should not exceed 0.25. Similarly, there are other two components, that is sulfur and phosphorus. So the limits are given here, 0.055 for ordinary grade, Fe500 ordinary grade, and 0.040 for Fe500D grade. So, and the phosphorus also given similar value. But one more, the stringent condition given by the code, individually if you look at the code, the sulfur and phosphorus, then what happens, we have to look into both combination, sulfur and phosphorus combined grade. So if you are adding this 0.04 and 0.04, you will get 0.08. But again, the code gives 0.075. So the chemical composition value, we have to be very careful. We have to test it in the laboratory and then confirm whether the bar, whatever we are using, it confirms both mechanical properties as well as the chemical properties. Now, these tests are already familiar to us. Whenever you talk about the bar, we do the tensile test, bend test, and re-bend test. Normally, it will be given to a testing center, and then we will get the test result, and we are going to compare and whether it is going to be fulfill the Codal requirement. Now, when you talk about the chemical and mechanical properties, I discussed about the chemical properties. Now, if you look at the mechanical properties, now there are very, very important. So whenever you talk about the yield distance of Fe500 grade, the minimum yield distance should be 500, and the ultimate tensile strength should not exceed, it should be minimum 545. And whenever you're taking a ratio, it should be 1.08. And again, percentage of elongation is going to be 12%, whereas for higher codes, it is going to be 14.5% for Fe500 grade, and it's going to be for D grade, it's going to be 16%. Because whenever you look at IS 13920, the code says that the higher strength steel like Fe500 and Fe500D can be utilized only if it is satisfies the minimum percentage of elongation of 14.5%. Otherwise, it should not be utilized for seismic, whenever high seismic zone area construction, it should not be utilized. So whenever you look at it, the percentage of elongation is going to be very, very important property. So IS 1786 gives the value of the limit, so that we have to verify and then use the material in our construction. Now, these are some of the tests given by the code, like a bend test. Whenever you bend the bar should not crack. The main purpose is, what is the bend test and re-bend test? We bend the bar for our structural purposes. So we have a beam column. So the beam bar has to bend inside the column. Whenever you are bending inside the column, the bar should not crack. So the limits are given here. So we have to follow this, and then both it has to fulfill bend test as well as re-bend test. The code gives what is the diameter you have to use for your mandrel. So that is given in the thing. Use that mandrel, and then we have to do the testing of that, and we have to qualify the bar. Now, one of the important points with respect to the code, IS 456, the very important thing is the cover requirement. Whenever the cover, I think the next lecture, Dr. Haji is going to give the lecture on the corrosion. Probably he will tell about all the how the bar is going to corrode, and then what are the failures and all. To protect the bar, steel bar, okay, from the atmosphere and again corrosion. So the important element, what is the important thing, what we have to do, we have to give the proper cover. So the proper cover we have to give. So cover is now based upon the climate condition. So earlier, whenever we use the bar, normally for the structural elements, we use nominal covers. For example, still some of the people are using the nominal cover for slab is 15 millimeter, and for beam 25 millimeter, and for column 40 millimeter, and for foundation 50 millimeter. So they use like nominal values like that. But as per the code, now you should not use the nominal cover. Now what we should use, we have to classify the environment. Now how to classify the environment? The code says that it classifies into 5 categories. So what are the categories are? Mild environment, moderate environment, severe environment, very severe environment, and extreme environment. So these are the criteria, these are the conditions laid by the code. The climates are classified into 5 categories. It is a mild category, moderate category, severe category, very severe category, and extreme category. So based on that, we have to choose the cover. For example, in the bottom of this slide, if you look at the table, even mild and moderate environment, even for slab, we have to use 25 millimeter cover. But whereas I told earlier, we use nominally 15 millimeter. No, it should not use 15 millimeter. So it's a 25 millimeter. Like that, if you look at it, if you are going for extreme environment, even for slab, we have to use 50 millimeter cover. Now, like that, if you look at the column, I told 40 millimeter. So minimum itself, now it's 50 millimeter and it goes up to 75 millimeter. Similarly, beam, we told 25 millimeter, it's going to 35 millimeter to 60 millimeter. So cover is very, very important because the cover is going to be the protected steel. But most of the sites, even they are not following the proper cover and they are not using the proper cover block. So whenever you are not using the power block, you will not get the durability of the concrete structure. The durability means you are building a structure and you may expect the life may be 100 years, but within 20 years or 25 years, it will start corroding it and it will create a lot of repair work and then rehabilitation work. And then it may lead to failure also. So whenever you talk about the cover, now the environment is going to be keep on changing. So because of the environmental condition, so we have to follow the Codal requirement very, very stringent with respect to the cover as given in the code. Now this is again the Codal part is given, nominal cover to meet the durability is given, and nominal cover to meet the specific to the fire resistance. Okay. Now fire, even the code says that you have to consider the fire resistance, fire rating of the building. Now whenever you talk about designing the structural element, for high-rise building, the minimum fire rating is 2 hours. We have to design for at least for 2 hours, the fire resistance of the building. Now, for fire resistance, the cover value is going to be much stringent. It is going to be much, much higher. When compared to the nominal cover with respect to durability requirement, the cover required for the fire resistance is going to be much higher. So the code again, in the table 16A, gives you the what is the nominal cover to be provided to meet the period of fire resistance. On the left hand side, if you're look at it, so it gives the hours. It gives from 0.5 hours, that is half an hour, to 4 hours is going to be the fire rating. So 0.5 hours, if you are using 0.5 hours, your beam, what is the minimum nominal cover you are given? So that is given here. So again, for 1 hour fire rating, what is there? So whenever you are talking about with respect to the nominal cover to meet the fire resistance with respect to the important element like column, so minimum is going to be a 40 millimeter you have to use. So that is what your fire resistance cover. So this cover along with your durability requirement cover, you have to provide for your structural member, and based on that, you have to consider your column dimension. So that is very, very important. Now, one thing is the minimum cement content. Normally nowadays, we use ready-mix concrete. So whenever you are going to use ready-mix concrete, normally we say that only what is going to be the grade of the concrete. We order to the RMC, we say that M25 grade concrete or M30 grade concrete. So like that, we are going to give some cover this minimum. Someone, I think someone is raising some questions. Sir, shall I continue or hello?
Sir, let's continue, sir. We will look at the questions after you completed, sir.
After completed. Okay.
Yes,
Okay.
sir.
Okay. So whenever you talk about the mild, whenever we order the concrete, so we order normally in RNC plant that grade using the grade only, M25 grade or M30. But we have to specify what is the minimum cement content, because whenever the mix designers, you know, whenever you are familiar with the mix design, you know that if you are using proper particle packing technique, or you are properly you are mixing this cement, sand, and the aggregate, and then what you can get, you will get highest strength also without following the minimum cement content. So whenever you use RMC plant like that, so without ordering M25, so sometimes what it will happen, they will not follow the minimum cement content requirement. So whenever you are ordering the minimum cement content requirement, so they will follow that minimum cement requirement condition, and then they will supply you your M25 grade or whatever grade you are ordering. So the code says that for mild environment, so the minimum cement content we have to follow is 220 kg per meter cube. So similarly, it gives the various values. So moderate 240 for plain cement concrete. This is for the plain cement concrete. And very important thing is reinforced cement concrete. If you look at it for mild environment, so the minimum cement content is 300. And then normally Chennai condition, we take like a severe condition. So minimum cement content is going to be 320 kg per meter cube. And then whereas you are going to be extreme condition, so it is going to be 360 kg per meter cube. So whenever you are going to order it, so we have to use, importantly, you have to specify the minimum cement content, and then you have to order the RMC concrete. Otherwise, what will happen, whenever we use in the site mix, so obviously you can follow this whatever M300, whatever the minimum cement content, and then you can make the concrete. But whenever you are ordering it, so you have to specify what is the minimum cement content, and then you have to order the concrete, so that whatever you are getting the concrete, it will have the minimum cement content. That is helpful for your durability of the concrete. Okay, so this classification of this condition, I talked about the earlier slide. What are the conditions are given for the paucity of time? So again, just I will give only one condition. Mild environment is what? Concrete surface protected against weather or aggressive condition, except those situated in coastal area. Okay, so mild environment is going to be like interior part. Like whenever you talk about the Tamil Nadu, the interior part like Salem, Coimbatore, Pollachi, so those areas are coming under this interior part. So interior part there we can use mild environment, whereas our Chennai and all will come under severe environment. So we have to follow whatever the minimum cement content as well as the cover requirement. So everything we have to follow as per the severe environmental condition. Okay, so corrosion. So why we have to protect the bar? That's what the bar is going to corrode. So it is going to be extensively covered in the next lecture. So I'll just skip that. So the corrosion is going to be, corrosion mechanism is explained in this slide. And then one important slide alone, I want to inform you that you can look at it. This is a corrosion map developed by the Central Chemical Research Institute in the 1970 itself. So from that, what we have to do, you look at it, the coastal region, both east coast and west coast are extremely severe condition. It will corrode excessively. That's what they have studied. Even they showed this climate, these conditions are very extremely severe condition. So it is will easily corrode. Whereas you go to the inner part, so it is going to be moderate and mild. So you can see that even in this slide, mild is only near this border of Karnataka and Andhra. Even you have a moderate environmental only you are getting in the interior parts of Tamil Nadu also. That is the findings of this Central Electrochemical Research Institute, Karaikudi. Okay, so this percentage I have explained already. So this is percentage of elongation is given here. For ductile bar only, it's going to be higher percentage. 500D 16% and 550D 14.5%. So that is very, very important. Now, with respect to the minimum size of the member, these are whatever I'm going to give. It is going to be the proposed change in the code. The proposed code is going to give these changes. For example, slab is going to be minimum 125 mm thick. Normally, nowadays we practice 100 mm thick concrete and as well as 115 thick concrete for the slab. But the code is going to say the slab is going to be minimum is 125 mm thick. And similarly, the beam dimension is going to be the 250 by 300 they are giving. And similarly, column, obviously, you know that we cannot use 230 millimeter column. We have to use the minimum column size is going to be 300 mm by 300 mm. So in the near future, once this IS 456 latest code is going to be in practice, it is in practice, that time we cannot use 230 millimeter column. So obviously we have to go with the minimum column size of 300 mm by 300 mm. Even whatever I am talking, even we talk about earthquake, we go for minimum 300 mm thick column size, 300 mm size column size. But even the IS 456 itself, the nominal, whenever you design for gravity load itself, what the code is going to be suggest in near future is 300 mm by 300 mm. And similarly, whenever you talk about structural walls, the wall thickness should be minimum of 160 millimeter. So the other conditions are given here. Okay. Whereas this minimum sizes can be relaxed for the low-rise building. So up to 3 stories, we need not follow this. There are some relaxations are given in the code. Now we talk about the slenderness of the cross section. Nowadays, what happens if you look at in the building construction? For example, one element I want to discuss about that, because there are the slenderness limits are given in the code: beam, column, and structural walls. Let us, for example, let us take only the column size. Okay, the column size, whenever you are talking about, the depth to breadth ratio should be less than or equal to 2.5. Now, most of the buildings, what happen? The 230 millimeter column is going to have 1000 or 750 millimeter is going to be long. So the code is not going to permit this in near future. So whenever you have to limit, whatever the width to depth ratio, it should be less than 2.5 only in near future. So accordingly, we have to follow the codal condition so that the structural element is behaving in a better manner. So similarly, it's given for the beam slenderness ratio is given. So mostly this is followed in the designer point of view. So I am just mentioning it here. Only this, there is a limit for slenderness for members for both beams as well as slab is given in the codal practice. Now, when you talk about the minimum longitudinal reinforcement, this is very, very important. Whenever you design the beam or column or slab element, the minimum reinforcement is to be provided as prescribed by the code. Now, what is the minimum beam size? Now, if you look at it, AST minimum by BD is given 0.25 by root FCK by Fy. So this is the formula is given. So you have to follow the minimum reinforcement for all the structural elements. There is a limits are given for minimum what you should use for beam, what is the value you have to give for column, and what is the limit you have to give, you have to minimum reinforcement you have to provide for slab, etc. given in the code. And now you know that for your own example, you may be familiar with the column. Just I am highlighting only the column alone. The column normally we use 0.8% is going to be the minimum speed. Normally we use 0.8%. There is a subclass given in the code. Okay, whenever you talk about the minimum percentage of column reinforcement, so you take a member and you can calculate what is the force coming on that, axial force coming on that member. The axial force which is to be resisted area, we have to arrive, and then for that we have to provide 0.8%. That means what? Whenever you talk about structural column as well as architectural column, whenever sometimes you provide architectural column, a big a circular column in the front of the building. So whenever you talk about that, it's for only architectural purposes. We are not using it for structural purposes. So as per the code, why should we provide more steel on architectural column? So there is a subclass also given in the code. But whenever you talk about the structural member, so we have to go for minimum of 0.8%. That 0.8% is going to increase. Now this new code, what you are going to say, then AS minimum percentage, even it is classified into concrete grade. So it's M20 to M40 grade, it is going to be 0.008 plus 0.0035. So approximately, if you are calculating exactly, it is going to be 0.835%. Now the code says that it's not 0.8, the minimum percentage value is going to be increased. It is going to be 0.835 for columns up to M40 grade. Suppose if you are going higher, the minimum percentage of steel is going to be much higher. For M40 and M60 grade, so the code of the minimum percentage of steel is going to be higher. So like that, the code is going to give the various value, the minimum percentage value for column as well as the structural walls, footings, rafts. Earlier we have seen what is for the beam. Okay. And similarly, the code says that you have to provide the minimum transverse reinforcement. Now earlier we talked about the longitudinal bar. Now it's a lateral bar that is going to be, it is going to be like transverse reinforcement, like stirrups. What is given here, slab, beam, column, and then structural walls are given. Okay, so that is there. So similarly for the minimum reinforcements are given, and similarly the maximum reinforcements are given. Now most of us always think that providing excess steel will increase the strength of the structural member, but that is wrong. Because whenever you talk about you are providing the more steel, your structure will become over reinforced section. The over reinforced section, obviously what will happen, the steel will not fail, the concrete will fail. The concrete failure is a sudden failure. So that should be avoided. So whenever we are using any section, the section must be a under reinforced section. So what happens whenever you are using the under reinforced section, the steel will fail. Whenever steel fails, the steel failure is a ductile failure. So the code says that whenever you want to provide, you should not provide the excess reinforcement. So whenever you don't want to provide excess reinforcement, the limits also prescribed in the code. Probably most of us are aware of that. So whenever you talk about the column, the maximum percentage of steel is 6%. But the practical purpose, we cannot increase more than 4% because we have to lap the bar. Whenever you are lapping the bar, suppose you for a structural element, if you provide 4% of steel, and then you are permitted to lap 50% of bar. For example, if you are having a concrete column, I am providing 4 bars at the corner. Each is having 1% reinforcement. Then what happens? The bar will have 4% reinforcement. Now I am lapping. The lapping rules permits that I can lap at a section only 50% of the bar. So I can lap at a section 2 bars I can lap. Whenever I am lapping the 2 bars, already you provide 4%. Now if you provide 2 lap bars, that will happen another lapping bar 1%. So that case it will come 6%. So at any section, so we should not use more than 4% of the bar. So whenever you are not using the 4% of bars, what will happen? Your structure is going to be not failure in a brittle manner. And again, whenever you may ask a question, sir, is a particular location, my column size is increasing. So what happens? What shall I do? I have to provide more number of columns. The structural thing, what you have to do, you should not have the more number of columns or what you should do, you increase the dimension of the column. So that will solve your purpose. Not increasing the steel is not permitted by the code because it will trigger or it will have the brittle failure. So the structure may collapse suddenly. Now the last part I want to give is very, very important part, that is IS 13920, that is ductile detailing. Now whenever you use the code IS 1893 for seismic load, now we say that we use a factor called response reduction factor. So there are 2 criteria. When shall I use ductile detailing? The code says that whenever you are in zone 3 and above, you should use ductile detailing. That is one part. The second condition laid by the code is whenever you are using the response reduction factor more than 3, that is 3 and above, now you have to use the IS 13920 ductile detailing bar. So what is the ductile detailing? So I am going to give very, very briefly about the ductile detailing. So one thing, whatever you know, first we talk about the stirrups. When you look at the stirrups, so obviously we are going to provide the stirrups hook. Okay, the stirrups normally we provide, but the code says that you have to provide the 135-degree hook. You look at that in the stirrups. The stirrups are 135-degree hook, and then again the hook length is given is going to be more than 10 times diameter of the bar. Suppose normally nowadays we use 8 mm stirrups, so the hook length is 80 millimeter. That is more than 3 inches we have to provide as a hook, and then we have to bend it. But this is what your ductile detailing. 135-degree hook you have to provide, and the length of the hook is going to be more than 3 inches if you are using the 8 millimeter bar. And then whenever you are using 10 millimeter bar, you have to use 4 inches. This is going to be the 4 inches. So we have to have this ductile detailing is going to be prescribed by the hook is for the transverse reinforcement is given here. That is very, very important. Now again, you talk about the ductile detailing. Now there is one of the very, very critical element is going to be the beam column joint. And then the beam column joint, we are not providing any steel at all. Okay. So the code insists that you have to provide the steel in the beam column joint also. So that is very, very important. Now, before that, I will look at it. I just explain about the beam detailing. So as per IS 13920, what is the beam detailing? Now, whenever you are looking at the bar, now if you look at it, the beam column joint, we have to provide the closer stirrups. Normally, the practice what happened, they will not provide any stirrups or they will not give the stirrups at this location. But the code insists that because the beam column joint is going to be very critical. So what we have to do is we have to provide the closest stirrups in the beam column region. So if you look at it, the beam region around 2D, where D is going to be your total span of the beam, 2D you have to consider, you have to provide the closer stirrups. And then the other location, you can provide whatever the design stirrups you can, spacings you can provide. So that is important. The other important point is lapping, where you should lap the beam bar. Normally, the beam bar, it should not be lapped at the mid zone and it should not be lapped at the support zone also. So you can look at it, it's a 1/3 location. Okay. So what you have to provide? So you have to provide the lapping. So that is given. And then even the lapping, whenever you are provide the lapping, you have to provide very, very closer steel. So that is with respect to your beam detailing. Now, whenever you are coming to the column requirement, now whenever you are coming to the column location, similarly the column lapping. Now, normally the people used to lap the bar above the floor slab. So it is not permitted. So normally the column also to be lapped at the mid zone. And again, if you look at it, the beam column, the column region around the distance, whatever given, there is a condition is given, at least minimum D or H/6 or 450 mm, we have to provide the closer stirrups in this region. So in the beam column zone, we have to provide the closer column stirrups also. And then, as I mentioned, you look at it in the red color, they have provided the beam column zone also, we have to provide the transverse reinforcement. So that is very, very important. So because this zone, because most of the cases, the shear triggers at this location, the failure occurs in this zone. And then because of that, we have to provide the minimum stirrup steel at this location that is denoted in the code of practices. Okay. So this is again. And then the bar bending is given. Normally we try to bend the bar LD distance in this only for top bar. For seismic zone, not only top bar, we also to provide the bottom also to the LD distance and then it has to bend on the upward region. So that is mentioned in this slide. Okay. Footing is very, very important. And then footing, whether the footing space and column location also, we have to have very closer steel we have to provide. So you have to use the special confining reinforcement for this region also. Okay. So that's it. So because of the time restriction, so I have just rushed it. So any questions I can now, I'm ready to answer.
Request the participants to go ahead with the questions.
Sir, thanks for your time and detailed session, sir. There is a question from Mr. Purushothaman.
Okay. Yes, sir.
Sir, so now you say nominal mix is only adapted for river sand live is 1:11 / 2:3. Then what is the standard mix? Is it for M sand?
No, M sand. No, that's what you have to do the mix design, not nominal mix. Nominal mix we should not be used now as per the code because there is a lot of variation in the material. We have to use only design mix. Even for river sand also, whenever river sand is not available, even river sand is also, you have to do the mix design. You should not use the nominal mix as per the code of practice. Why the code of practice is saying that you have to use the design mix means because there is a lot of variation in the material.
Okay. Okay.
Okay. So that is the reason we should not adopt the nominal mix. We have to go for only design mix, and then it is not 1.5:3. So based on the variation in the material, it may be 1:1.6 3.2. Like that, the variation will come. Depends on the variation in the material. So that has to be done in the laboratory or in the site itself. There is a proper mix design procedure is given in the code of practice. You follow, you do the sieve analysis and all the basic property of the cement test, aggregate test, and then you can do the mix design and arrive at this ratio. After arriving at this ratio, you again cast the cubes and test in the laboratory whether you are going to achieve the grade of the strength. Then you can adopt that ratio in your construction.
Okay. Thank you, sir. There's one more question from Mr. Venkatraman.
Okay.
What grade should be used in individual houses? Is it for G+1 or G+2?
So the minimum is M20 grade. We can adopt structural grade concrete is minimum M20 grade. But whatever, if you are severe, considering the severity, considering the environmental, whatever I talked about the cover, that is the climate change, and then the environmental classification like mild, moderate, severe, very severe, and extreme severe, extremely severe. So considering these conditions, what you have to use if you are in Chennai, even it's better to use M25 grade. But
M20.
you should not go below M20 grade. You should not go below M20 grade. Even if it's a G+1 house also.
Okay. There's one more question from Mr. Purushothaman. To build a structure in coastal areas, which type of cement and grade are used?
Sir, that's what the code says, that you have to go for minimum is M25 grade. As I told, the minimum is M25 grade, and then you can go for M30 grade also. Minimum, the prescribed level for the coastal zone is M25 grade. That is again code given in the Codal provision itself. But whenever you talk about the special purposes, whether you are talking about the chloride or sulfate, even you are the many projects based upon the sulfate and other things, they have given prescribed the sulfate resisting cement also. Now you talk about some of the environmental structure like sewage treatment plant or the water treatment plant, everything they are using where they use sulfate resisting cement also. So it is based on the purpose, and then you do the study on that location and then adopt the grade and then type of the cement also.
Okay, sir. The next question is, sir, now we are using M sand for concreting work, but we are facing the cracks on the roof concrete. How it will be avoided? We are using double water wash M sand and mixture also.
Okay. Sir, that's what whether they have done, because this whatever whenever you talk about this condition, whether they have done the proper mix design, that is the first question. And then we have to test in the, normally what now in the practice, what happened, the M sand manufacturers are giving certificates. So the people get the certificate and then they adopt the material. But whenever you are coming to the site, the material, there is a lot of variation in the material. So that we have to do the field testing. In the site also, we have to test the material, and then we have to adopt we have to use good construction practices also. But whenever you talk about the shrinkage and other property, so what happens, you have to go for even the admixtures, the special type of admixtures are available. We can use that. Because whatever you are going to be, because it is based on the material. So we cannot give the generalized solution for particular thing. Okay. So if it is a generalized solution, M sand means you should not use, you have to use like that, we cannot generalize it. Because it varies with respect to the material. So based on the material, they have to adopt the minimizing the whatever the shrinkage cracks or other cracks, you have to do it. It's based on the trials. They have to do the field trials, and then we have to report the problem and then get the expert opinion, and then they have to avoid that type of thing. We cannot say generally this is the solution for the particular thing, because the variation in the material is more.
Okay, sir. So there's one more question from Mr. Sharan Kumar. When should we consider seismic load in structural design? Is it only considered for high-rise buildings?
According to the code, even you are designing G+1 also, you have to consider the IS 1893, and then you have to design for seismic zone. Now, whenever you talk about that, even there are the cities, like if you look at it, Bangalore city comes under zone 2. Okay, very less zone. Okay, seismic also classified into 4 categories: zone 2, zone 3, zone 4, and zone 5. So whenever you talk about Chennai and most of the Tamil Nadu comes under zone 3. So obviously we have to consider IS 1893, and then we have to design for seismic loading also, even you are building a low-rise structure also.
Okay, sir. I think that's all we have for now, sir. Let me check if we have any more questions left.
Any other question? Satish?
No, sir, I'm just looking at it. I think that's all we have, sir.
No, rest of the questions we can take mail, okay? Because
Sure,
for
sir, we can
want
do
of
that.
time, okay, we
Yeah.
can do it later.
Okay.
Thank you very much, Dr. Senthil, for your incisive and excellent lecture laced with valuable information. I hope the participants would have benefited from your lecture.
Yeah.
Thank you once again.
Yeah.
Thank you very much.
Sir. I thank the high skill authorities and also Professor Santha Kumar. And
Thank you, sir.
Yeah,
Thanks a lot.
Thank you.
Thank you very much.
Thank you.
Now, I would request Dr. Radhakrishna Pillai to take the place for his lecture on. Hello.
Yes, sir, we can hear you. Radhakrishna Pillai has got
Now I
disconnected.
would Radhakrishna Pillai, who is
He got
associate
disconnected,
professor
sir.
in IIT, he got disconnected.
Yes, sir, I think he got disconnected. He was here only, suddenly got disconnected.
There is okay. There is one more question. Has he left? Dr. Senthil has left.
Yes, sir. He just left. Yes, he also left.
Hello, Dr. Radhakrishna. Or can we advance his lecture then?
Actually,
Haji, sir.
No, actually now I
Haji's.
I had talked to Dr. Pillai. He is just connecting now.
Okay. Okay.
Oh,
Actually,
okay, sir. Okay.
my lecture should follow his lecture. Then only order should be.
Correct, correct. I understand. That is how we have fixed it.
Yes. He is joining now.
Okay, okay, sir.
Yes, doctor.
Yes, yeah. Actually, I was there. When I opened my PowerPoint file, it just the screen got stuck, so I had to close it and open.
It's okay, sir.
Okay, welcome, Dr. Radhakrishna Pillai.
Yeah.
So now Dr. Radhakrishna Pillai will speak on corrosion, chloride threshold value of steel, and its impact on service life. Dr. Radhakrishna Pillai is a associate professor in the Department of Civil Engineering, IIT. Now I request Dr. Radhakrishna Pillai to go ahead with this lecture.
You have to enable me to share the screen.
1 minute, sir.
1 minute, yeah.
Yeah, I just made you, sir. Yes. Got it, sir?
Yeah. Can you see my screen?
Yeah.
Yes, sir. We
Yeah.
can.
Yes.
Yes, right?
Yeah, yeah.
Yeah. Thank you for iSteel to coordinate this program, and I think it will be really useful for the practicing engineers. And as you said, we're trying to talk it in a lighter manner. So what I'm going to talk about is corrosion mechanisms, and one of the key parameter, which is chloride threshold of various steels and its impact on service life. So this is the overall thing what I'm going to talk about. This is also whatever I'm going to show is based on 3 PhD projects which are happening under my guidance in IIT Madras by Dr. Sri Priya Rangaraju, Deepak Kamde, and Diana Joseph. So first I will brief you on carbonation-induced corrosion and chloride-induced corrosion. These are the two major corrosion mechanisms which happen in concrete structures. And then we will talk about how the service life of uncoated rebars, essentially TMT rebars, and we'll also talk about some of the quality related issues of some of the TMT rebars in the market and what we should be looking at, how we should select TMT bars. Okay, and then we will talk about the adverse something about the coated rebars, mainly the epoxy coated rebar, and how, what are the concerns about the epoxy coated rebars? Are they really giving what we really expect from those rebars? And then also some corrosion mechanisms in pre-stressing strands. And towards the end, I will talk very briefly on how to protect some of the existing structures, because we have a huge inventory of our structures with fusion bonded epoxy coated rebars and pre-stressing strands. So how do we protect them? So that also, I'll just throw a light on that depending on the time available. I'll try to wrap up in 45 to 50 minutes, and then we'll take some questions. So before starting itself, why we have to really focus on materials. So this is from Dr. Vedalakshmi in Sekri, Karekudi. She did some study and then came up that, found out that about 42% of the structural failures are actually because of material failure. See, we have, traditionally we focus mainly on structural aspects, and less importance is given, has been given on the materials aspects, which is very, very important. We have to really focus more on materials now, or more importance have to be given for materials and how they perform. And when I say materials, again, in materials, we give more importance to cement and concrete and not to the steel. So that's another aspect which I want to emphasize. We also should be testing steel rebars not only for their mechanical properties, but also for their other properties, like corrosion related properties, before we select a bar for large projects. Or in other words, more routinely, we should test steel, okay? And nowadays, if you ask any project manager, you will see that they will just test only the ultimate tensile strength. That's all what they do, maximum. Maybe one more thing is the yield strength. But if you look at, modulus and all that, especially with the TMT steel, which we have in the market, there is a huge variation in all those properties. And also we see a lot of steel with much higher strength than what is expected from them, which leads to moving from the under-reinforced structure to an under-reinforced system to an over-reinforced system. So for example, if you have a 415 steel, you will see that the actual yield strength is much more than that. And it keeps on going because there is no upper limit specified in the codes, which is being specified right now, and the work is going on in that line. Anyway, point here is materials needs more focus. Now, in material, we have steel and concrete. And when you talk about durability, it's essentially the cover concrete which is more important than the core-crete, or the concrete near the periphery of the elements are more important. And that is what really influences the durability of the structure, and also the steel. So synergistic effect, how the steel and cover concrete work together to protect the structure from corrosion in long term. That is what is our approach. And synergistic effects need to be considered. In other words, what I mean is, if you use stainless steel and a poor quality concrete, it may not last as long as needed. At the same time, you cannot go for stainless steel all the time because of the money, but we have to see which type of material is useful and is required. If you're talking about multiple centuries, then maybe you should go for stainless steel, okay? Anyway, now what are the essential parts of a corrosion cell? So here you see on this diagram, there are 4 essential components. Imagine a battery which you have positive terminal and a negative terminal, which are essentially anode and cathode. And then you have an ionic conductor and a electronic conductor. So in steel and concrete system also we have similar way. Over here, the gray portion is the steel rebar, which you can assume, and the yellow portion is the concrete, which is. So you have pore solution in the concrete, which helps in completing this electrochemical circuit. Okay. So you have an anode, but that is the location where the steel corrodes. You can see the shape change here, and a cathode which helps this anode to corrode, and the concrete which provides the path for the ionic conduction, and the steel itself which provides the electronic conduction. Now, when you look at the electrochemical reactions, if you're looking at a pile, let's say this is the picture of not a palm tree, but it is actually a reinforced concrete pile. And as the pile is coming out of the water, you can see that is where you have maximum corrosion or maximum degradation, because that region experiences wetting and drying, which is much more severe than complete submersion. So for example, if you go down on this pile below the water level, you will not see much corrosion as you will see at the water level. Right here, you will see more. As you go down, you will see less. As you go up also, you will see less corrosion. Okay, degradation rate is less. The point in this slide is that for corrosion to happen, you need both oxygen and moisture. So if you can prevent the structures from either oxygen or water or moisture, you can prevent corrosion. But it's almost impractical to achieve that. So wherever there is oxygen and moisture, you might see there is a possibility of corrosion. Now here is how it happens. You can see at the anode side, you lose the iron or you lose the steel, and that Fe2 plus reacts with the hydroxide ions, which is coming or which is available in the concrete environment, and that combine it forms FeOH2. I mean, let's not go too deep into this. Just assume that if you have some steel in water, some location will corrode and some will not corrode. But you need to have oxygen and moisture. That's the main point here. You need to have oxygen and moisture. If you can prevent the availability of oxygen and moisture, we can minimize most of the corrosion. We can almost stop it, but it is very difficult. Now, when it comes to concrete structures, the previous picture was on steel in water. Now, when it comes to concrete structures, what you have to see is there are 2 types of corrosion, or the way in which the steel undergoes corrosion. One is because of the carbon dioxide present in the atmosphere, it penetrates into the concrete and it leads to corrosion. The other thing is the chloride, which penetrates into the concrete and eventually leading to corrosion. The major difference between the two is if you see the pictures on the right side, in the case of carbon dioxide induced corrosion or carbonation induced corrosion, you will see more or less uniform loss of metal. Whereas in case of chloride induced corrosion, you will see that the loss is like in the form of pits or some localized corrosion, which is dangerous. Because in this case, I can actually estimate what is the remaining cross-sectional area available. Whereas in case of chloride-induced corrosion, it is very difficult to estimate this, and then you will have much more localized, local stresses will be generated because of this pitting corrosion. Okay. Now, this is a typical service life schematic for how a service life would be for a concrete structure. You can see carbon dioxide penetration, and then when the pH at the steel surface reaches about 9, usually the fresh concrete will have a pH of 12 or more, okay, or even 13. For example, if you keep a wet cement paste on your hand for a long time, you will see that your hand gets smoothened, or rather your skin is lost. That is because your skin is not well protected against high pH. But in case of steel, steel really likes to be in the high pH environment so that it will not corrode. And that is why we are actually using steel in concrete, because the concrete has a very high pH at which steel will not corrode. But because of carbonation, when carbon dioxide reacts, eventually the pH will reduce and then the steel will start corroding. And that is a time when we say the corrosion initiation happens. So if your cover concrete is very good, and if it resists the entry of carbon dioxide, then you can have a long life for your structures. Okay, these are examples of structures. This is from Chennai Metro. You can see that it is exposed concrete. You have a lot of vehicles below that. They are all pumping CO2 into the environment. And so the local environment for this structure could be, it will have high concentrations of carbon dioxide, unlike what you will see in a paddy field far away in the rural area. Okay. Now, what is that severe condition for carbon dioxide? If you have a 60 to 70% relative humidity, then the carbonation rate is going to be very, very high, or maximum 60 to 70% relative humidity. And we have a lot of region near the coast or few kilometers into the, near the coast, where you might see 60 to 70% relative humidity and a lot of CO2 in the vicinity of the structure or in the immediate surrounding. Because we have a lot of coastal cities like Chennai, you have a lot of carbonation issues in Chennai also. So this is what it happens in case of carbonation. You have carbon dioxide enters from the atmosphere into the concrete cover. It reacts with the calcium hydroxide in the concrete. And when calcium hydroxide is consumed, the pH decreases. And when pH decreases, then the steel will not be able to protect itself. It will start corroding. So this is a typical corrosion which you will see, uniform corrosion. This is a and how can we test it? You can actually use phenolphthalein indicator, which can be sprayed onto the concrete surface, and you will look for this region which is colorless and pink color. Like you remember in your chemistry class, where you might have done this test and looking for in a pipette or in a burette where the color change happens. So the region which is colorless is actually carbonated region. So how to remember this is, just remember pink is good. Okay, so if a steel is in the pink region, it is good. If the steel is in the colorless region or in the gray region, it is already carbonated, the steel can corrode. So here is an example picture where you can see that the carbonation happened. This is the cover concrete. Carbonation happened here. In this region, the pH is less than 9. And in this pinkish region, which you see, the pH is greater than 9. So the steel is safe. At least you can see here at this stage, the steel is safe in this case. But if you wait for some more time, you will see that the carbon dioxide penetrates further and steel will then start corrode. So you have to see how to make the concrete highly impermeable to carbon dioxide. Okay. So ideally, I found this picture from the internet, but this is not a good practice. You should never take a core with the steel rebar cut. You should not cut the bar while taking the core. But anyway, for demonstration purpose, this was good. So now in case of chloride-induced corrosion, there is a critical parameter which we call chloride threshold. Okay. And that is again, the chloride penetrates into the concrete and it reaches the steel surface. The black circle here is the steel. And it reaches the steel surface, and when it starts building up, when the chloride concentration is above a particular value, then the steel starts corroding. And this value is very high for stainless steel, whereas it's not that high for our normal steel. And we will also show you how it is for fusion bonded epoxy coated steel and pre-stressing steel. Now, where do we see chloride induced corrosion? Wherever you have access to seawater or airborne chlorides. Okay, you might see a lot of corrosion due to chlorides, because chlorides will penetrate through the concrete cover. It will enter and reach the steel and then eventually corrode the steel. Okay. And you can see this is from a temple. You can see wherever you put a lot of cement in your system, there is a tendency that system may not last too long. You should not use cement as a filler in your concrete. It should be used as a glue and just enough cement. As small as possible, the quantity can be minimized so that most of the degradation processes are going to be controlled better. So lower the cement, it is better. Okay. So let's not use cement, because sometimes we hear, if you want to go for higher strength, the first thing to talk about is increase the cement. That is not the right approach. You should go for a proper mixed design with maximum aggregate possible. And that's also going to be less. And also we can use SEMs and all that. This is again some picture showing corrosion issues on the coast near the seashore. This is in Chennai city, one of the footpath, crossover, pedestrian crossover. You can see here, and at the bottom you have a road. From the top, it looks very nice. These people don't even know how badly these slabs are cracked. You can see here how badly they are cracked. So how long we will be able to protect this is a big question. So we have to really think about prevention of corrosion before they even start. And this is a picture from a chemical plant where HCl, hydrochloric acid is made. You can see the slabs are all cracked, severe chloride. So wherever you can have a high amount of chloride, you should really design the structure for durability and not just strength parameter. In other words, the concrete should not be just based on strength. We should also think about durability parameters. And how to protect. Cathodic protection is one way to do it. This is a photograph from a structure which is just 5 years old. What happened is they used the sand or water which was having high amount of chlorides. Even the borewell, if you take water, you should check whether the chloride content is high or not. If it is high, you will have a lot of problem. This is widespread especially in our city, where if you look at the structures which are built around 15 years old, you will see more corrosion than the structures which are older than those. Because earlier there was no shortage of water much, but around 15 to 20 years, there was this, two things. One was sand mafia and the other one was the usage of groundwater. So both these might have had a lot of chlorides and they are present in the concrete, and it is leading to accelerated corrosion, in short period of time. So, and cathodic protection is probably the only way for such type of structure where chlorides are already entered, and how to protect without, demolishing the whole structure. Now, when chlorides reach the steel surface, it attacks this passive film, which is the protective layer on the steel surface. That protective layer is nothing but, like in our copper vessels, you will see green color patina. Similar thing forms on the steel surface also when it is embedded in the concrete. And that steel patina, or similar to patina, the layer we call it as passive film. Now, when chlorides reach the passive film is getting broken first, and then it starts corroding the steel. Now, in presence of chlorides, moisture, and oxygen, this can become like a catalytic reaction. So the moment you have good amount of chlorides, then steel will start corroding, and then that corrosion is very difficult to stop unless you stop the availability of oxygen and moisture. So this is why it is very, very important to test the chloride threshold and make sure that your steel has very high or very good resistance, and at the same time, more importantly, that the concrete cover is very, very good. Okay, if you can put one more inspector at the site to take care of concrete cover, that will be the best thing to do. And concrete cover depth, and also the quality of the concrete cover. That means you have to have a person whose job will be only to look at cover depth and curing of concrete. These two we miss in many of the sites, and that is why most of our durability problems are coming from. I mean, that is where they are arising from. So we must ensure that cover provided is sufficient, and also curing is properly done. Okay, it's very important. I don't have a slide on curing, but I think came to my mind. I think that is very, very important to talk about curing of concrete. Especially today we use fly ash, slag and all that. And if you don't cure it, you will not get good quality concrete. It's very, very important. And an analogy is that like a curry, or any, let's say you make any curry, for example, all the vegetable comes from the same market, but the way you cook will determine how tasty the food is going to be. Similar way, it's not about just using the mix design properly, but also the implementation at site is very, very important. You have to really make sure that the mix design is really implemented at site, and also the sufficient curing is provided for the concrete, especially for the cover concrete. And you should not let the surface dry. You should always ensure that you have sufficient water available at the near surface or at the surface of the concrete, so that you will get a very good cover concrete. And that is very, very crucial for achieving durability. Okay, now pitting corrosion I mentioned earlier. When this chloride, this is the way in which it corrodes. You don't see corrosion everywhere, but some locations here and there you will see corrosion. This is the first picture is a strand, and second picture is a typical. You can see a pit happening here, pitting corrosion, but there are regions where there is no corrosion also. Now we developed a test method to determine the chloride threshold, and I'm not going to deeper into this. Basically, this test method just has a steel rebar inside this small, it's a 10 centimeter long rebar. It's and like this. And then what you do is you expose that to chloride, and then eventually we can determine the chloride threshold, or we can determine when the steel will start corroding. When the steel. Now you see this picture. This is very, very important slide. And here you will see that an uncoated rebar will have a chloride threshold of about 0.4. That is the black circles which you see here. Uncoated rebar. If you have a coated rebar, like an epoxy coated rebar or a non-metallically coated rebar, the threshold is typically found to be very low because you always have these cracks on the bars. This picture shows that crack is very, very severe crack. Okay. Yeah, and which is very common on most of our construction sites. Almost all sites which I have visited, I have seen that they are using bars which are scratched. So you rub the bar, you drag the rebar on the site, you do all sorts of things to this rebars, which are not good. And also you have sunlight exposure. If you expose the epoxy coated rebar for about a month or even less than that, you can have cracks on epoxy. You see this picture very closely. You can see cracks here. This is a specimen which was exposed just for 1 month. So all our structures where you will, if you are seeing the rebars popping out of concrete for more than a month, guaranteed that it is going to have a low life or shorter life in terms of corrosion initiation. They will start corroding at an earlier time than an uncoated rebar. So the question is, why do you want to spend extra money on the epoxy coating where it is not going to be adequate? However, I must say this also, if you can ensure that there is no sunlight exposure and no scratching or any mechanical damage of these rebars, then you will have much longer life. Okay? But it's very, very impractical. So the message is, if you cannot ensure that these bars are protected or treated like babies at construction sites, you should not go for epoxy coated rebars. Okay? Similarly, for unstressed strand also we determine chloride threshold, but when you have stress, the chloride threshold is much lower, almost 50% less. So in reality, all the structures we will have stressed strands. So their chloride threshold is half of the chloride threshold of unstressed case. Okay, so these are just numbers, very important. And we also have developed a nomogram, set of nomograms to enable the structural engineers to design for durability. Okay, so the idea here is you start from here where you have cover depth and an accepted probability of failure at the time of corrosion initiation. Okay, this can be decided in the structural design office. And once you decide that, you decide what is the binder to be used, whether I want to use fly ash or slag or only OPC or LC3 or different type of binders or cementitious materials. Once you decide that, you pick the corresponding curve here, and then you tell whatever your desired service life is. For example, let's say I want a life of 100 years. Okay, then my target, I mean, I'm going to pick this curve here, the target. So based on that, this target service life, I can decide a target diffusion coefficient for the concrete. Now, this can be given to the site engineer and ensure that whatever concrete they use should have a diffusion coefficient of this much, in addition to the strength. So I'm going to call this as MXDY concrete. Okay. So nowadays we talk, what is your concrete? People will say it's M30 or M40, something like that. But we should also add another term here, whether what is the durability factor or diffusion coefficient of that concrete. When you talk about chlorides, we should talk about diffusion coefficient of chloride diffusion coefficient. So I can have an M40 concrete which has different levels of chloride diffusion. And if the chloride diffusion coefficient is very low, then that concrete will be very good. If the chloride diffusion coefficient is very high, that concrete may not last for a very long time, even though your strength may be sufficient. So MXDY concrete is one message. Now let's talk about the steel. We are talking about, today we use TMT steel. What is TMT steel? Okay, it's the steel which is tempered martensite ring, which has a tempered martensite ring or here, and a ferrite perlite core. This is how the cross section of a TMT steel looks like. There are different patented technologies available, as you see on the left side. And, but in India, mainly it is Temcore and Thermex technology which is used, but more or less they are all same technology. Essentially, the point which you want to remember is that the steel which you have, when you cut that steel and look at the cross section, you should see something like this with your naked eye. You don't need a microscope for this. Okay, naked eye. This is just a photograph taken using a cell phone. So you can see something like this. You can do that test at sites. Now we have done some tests already, and I'll show you some results, alarming results which we got from industry. I mean, various products available here. So which is very big concern. So this is how the cross section should be, and I'm going to show a video on how the how the steel is manufactured. Let's see. You can see here. I'm trying to play this, but it's not letting me play.
So sorry to interrupt. I think sometime during the share screen, the video doesn't play.
Oh, really?
Sometimes it happens. You'll have to maybe play that separately. We have faced this in the past.
Yeah, it's happening.
Okay.
This is Yeah, I think I just wanted to emphasize on the TMT manufacturing process. So essentially the outer ring, or I'm going to call it TM ring, it's formed mainly because of the quenching and self-tempering process. So technically this bar is called quenched and self-tempered, or QST rebars, and TMT is, any steel will go through thermomechanical treatment, but in our country we have been calling it TMT, so we will probably continue to call it TMT also. But if you go out of country, you'll see that they are all known as QST rebars, or quenched and self-tempered rebars. Now, this is a TM ring test, which is already there in 1786, but people don't follow that much for qualification or for acceptance or rejection of the rebars. So I think this is something very important, and TM ring test. So you can do this at any construction site. Take the bar, cut the rebar, and then take an emery paper and rub the surface, and you will be able to rub the surface and then dip it in a solution. I'm going to show another video here to show you how to do this test. You can see this. On the left side, you have a poor quality TMT bar, and on the right side, you have a high quality TMT bar, or a good quality TMT bar. When I say quality, I'm meaning the TM ring. Okay, so you look for the left side, the darker region on the periphery is not properly a circle, not a proper circle. Whereas on the right side, you will see a perfect circle forming, right? Perfect ring is formed. So the right side bar is a good bar, whereas the left side bar is not a good bar. What is the problem with this? The ring is not, the ring is not proper. So this is examples of how the some of the bad quality TMT bars look like. On the left side, it's a good one. You can see a proper ring. And on the right side, you see that it is not proper. This looks like a crescent. This looks like a flower. So, sunflower petals, and this looks again something, very, non-uniform cross-section or non-uniform microstructure of the cross-section of steel. This is something very important, and we are using a lot of TMT steel today, so we should really check, are they really TMT steel, which we want, okay? Problem is this. You see, this is again more pictures from the various rebars available in the market. You can see, as the rebar diameter is smaller, this problem is more prominent. You don't have good quality TM ring on the smaller diameter bars, and this is why we have corrosion on our stirrups. Most of the stirrups we have either 12 or 8 mm diameter rebars, and they have smaller cover also. Stirrups will have smaller cover. And because of this small cover and the stirrups having poor quality TM ring, we are seeing a lot of corrosion of this TMT rebars. Okay. Now again, on a mechanical problem, what is the problem if we have these inappropriate TM rings? When you bend it, you will see significant cracking or peeling off of these rebars. You see, on the picture on the left side is a picture where you have a good quality TMT rebar with a proper TM ring, like this on the left bottom. Like this on the bottom, and when you bend it, there is no cracking happening or no peeling off of the TM face. Whereas you have a poor quality TMT bar, where when you bend it, you see a lot of cracks on the bar, on the surface. It's getting peeled off. The TM face is getting peeled off, which is going to create a lot of problem, because in this case, you don't want any chlorides for the steel to corrode. It will corrode with very minimal amount of chloride. The mechanism is crevice corrosion. You don't need any chloride for the bar on the right side to corrode. So it makes it very, very important for us to test the TM ring. It's very important. And especially we use these for stirrups. And for stirrups, especially for earthquake resistant design, we bend them for more than 90 degrees. We must bend them for more than 90 degrees, and then there will be a lot of cracks on the peripheral region. You see this side will get cracked. Now, also I'm going to show you something about the bend test. Professor Senthil already mentioned briefly about this. Next picture I'm going to show is from the site. So we do this bend test. We are supposed to do this bend test. I don't know if we do this bend test on every site, but we are supposed to do this bend test. So this is some pictures from some sites where you can see while bending, the bar gets cracked. These are also TMT rebars. These bars get cracked. So what will happen if you have cracked like this? This bending has no use anymore on the structure. It will not develop as much it is designed for. So these cracks you can see here, big cracks, and here also crack. Why is probably they have not used, either it has a big TM ring or they have not used a proper mandrel diameter. So when you go for larger diameter rebars, you should also take an adequate check on whether you are using a correct mandrel or not. Otherwise, the bar will crack. Okay, so it's very, very important. Now, epoxy coated bar, these are some of the photos from the sites showing exposure to sunlight. You see these columns, this is from Mumbai. It will just lay like that for several months. There's no way this portion is going to be very well protected or as expected, the protection level. In other words, the epoxy coating will not be able to do its job if it is cracked. Okay. Now, these are some more pictures from sites. You see the well bending. See, abroad, when they use epoxy coated rebar, they don't bend the rebar after the coating is applied. They bend the rebar before the coating is applied and then send it to the factory and then get it coated and then sell it back. They bring it back to the site. These are some images showing scratches on the bar. These bars will not have any resistance against chlorides. And this is a picture when it is exposed to sunlight. Okay, so you have cracks. So, and also we have a lot of pre-stressing strand. This is one mechanism. I think because of shortage of time, I'm going to go a little faster. See, unlike normal rebars, solid rebars, the pre-stressing strand has some space in between the 7 wires on a strand. So what happens is when the corrosion happens, the initial corrosion products will go and occupy the space in between these 7 wires. Okay. Now, because of this, it takes much, much longer for that concrete to crack, or we will not be able to see any rust stain when you inspect a pre-stressed concrete structure, even though there is significant corrosion inside. Okay, that's very important because usually when we talk about reinforced concrete structures, we look for rust. If there is brown stains, then we say, oh, something is happening inside, we have to check. But in case of pre-stressed concrete, we will not be able to see that rust, okay, until it is too late. So we found that until about 6% of total area is lost, we will not see any expansive stress onto the concrete cover. Okay. Now, also because it is a pitting corrosion and it is localized corrosion, you will also have a lot of the space all along the strand, which will occupy the initial rust products. Okay. Now, this is an example from a bridge in New Zealand. You can see this portions inside these red boxes is almost nothing left over. And even on this bridge, which was just 40 years old, even on this bridge, there was no stains visible on the concrete surface, but then the bridge collapsed. So this is the danger about pre-stressed concrete. So we have to really take more care about pre-stressed concrete structures, and they are not like conventional reinforced concrete structures. Now this picture I already showed, that chloride threshold. Now I'm going to briefly show a case study, or going to go a little bit faster. We did a case study on a coastal bridge where we found that if you use an uncoated bar, you could have about 90 years of life, which is this black box here. And if you use a coated bar, epoxy coated bar, because the chloride threshold is very low, and if it is not damaged at all, if there is no damage and perfectly handled like a baby, you can have long life, no issue. But as we see on most of our construction sites, we see either they are exposed to sunlight or they are having significant damage, mechanical damage, scratch damage. Because of those, the life is significantly lower than even an uncoated rebar. The question is then why do you want to coat these bars at all? Because it costs 30% more money. So there's no much benefit of using epoxy coated rebars. Now, other important thing is why I'm showing this slide is we have a lot of structures already made with such rebars. So what do we do with those structures? If we are within 10 years, if we apply surface coating, we can probably protect those structures very well. But if the structures are 20 years old, then the protection level is not going to be really good. If the structure is almost 20, more than 20, then the protection, even surface coating will not help much. Okay, so we have for all the structures which are already having epoxy coated rebars, we know what conditions those bars were used at. They have scratches, they were exposed to sunlight. I highly recommend that we start a mega projects on coating all those structures as early as possible, so that we can prevent further entry of chlorides into those structures. Okay, that's very, very important. And in some cases, if the structure is already older than, let's say, 20 years or something, then even coating will not help. In such case, we have to electrochemically address the problem, and cathodic protection is the best technology available today for such things. It's the least expensive and easy to not say easy, but it is the most efficient technology for enhancing the life to a larger extent. Okay, so cathodic protection is very, very useful in such cases. And if the structure is very, just a new structure, then we can probably go for, coating applied on the concrete surface. Here I'm talking about coating the concrete surface. Okay, but we should do it as early as possible. If it is more than 20 years old and all that, no point in investing money, because you have to keep on redoing the coating also. Now, considering epoxy coated, these three graphs, how this coating will help. If you're talking about 5 years old structures, we can actually coat them and we can extend the life up to about 80 years. I mean, these numbers are based on the case study which I'm showing. And if the structure is already 10 years old, then we cannot really extend the life much. If it's more than 10 years, then it's better to go for cathodic protection. But in epoxy coated, we still have to see how to cathodically protect it, because there is a impermeable non-conductive layer of epoxy on the rebar. So they're more tricky. And for pre-stressed concrete, we can still, again, if it is 10 years old, we should actually think about coating the concrete surface so that we can really enhance. The main problem with this pre-stressed concrete is that you cannot really detect the corrosion initiation with the usual visual observations. So we might allow, Now, another concept I want to emphasize here is the, how we are repairing the structures today. Most of the structural repair which we see today, we see that they go for multiple repairs. Very often they go for multiple repairs. Every 6-7 years, you will see that they are getting repaired again and again. This is mainly because the underlying problem of corrosion is not addressed adequately. So the picture on the left bottom, you see it's a cooling tower of a power plant. And about 3 years ago, what one of the repair contractors or agencies, they recommended to provide FRP coating, FRP laminates. You see on the picture on the left top here, you can see this belt-like laminates applied on the structure. This is the funnel of the cooling tower. But what happened is in just 3 years, they cracked, the FRP laminates cracked severely. And this, again, you can see zoomed in how badly it is cracked. And then now the structure is being demolished. And the problem is, when they applied this FRP laminates, they did not think about stopping or arresting the corrosion happening. So, message here is, when you go for a structural repair, first thing to look at is what is the root cause of the problem. And do not do a structural repair unless the root cause is addressed. So you have to address the material problem and then you go for structural repair. So this FRP laminates were not strong enough to handle the expansive stresses coming out due to the further production of rust inside the concrete. So first thing was to arrest the corrosion. So in such cases, cathodic protection or some way, mainly cathodic protection, because I believe that that is the way to go for most of our structures which we have corrosion problems. Okay, because there are other repair methods like patch repair doesn't really function well for long term. So if you're really looking for long term hassle-free repair procedures, then look at the options of cathodic protection, and then in addition to that, go for better cover concrete and with enhanced properties, and also then the additional confinement which can be provided from FRP and systems like the structural repairs. So first you have to handle the root cause, understand the root cause before you go for any structural repair. Now, one last aspect I want to mention here is the effect of cover depth. I started also by saying the cover depth is very important. You employ one person just to take care of the cover at sites. His job should be just to make sure that cover is very adequately maintained at all locations on the structure, not just here and there. And also, you can see here, if cover depth is maintained, how much difference you are seeing in the, the service life. You can see if a 30 mm cover, if a structure will last for 20 years, by increasing the cover to 40 mm, you get a 50% increase. And so the message is you can have about 65%, let's say more than 50% increase in cover with every 10 millimeter. I'm not saying that you keep on increasing the cover. That's not the solution. But what I'm saying is whatever is as per the design, make sure that cover is there. Because I'm seeing many structures where you have zero cover. You can see the rebars. When you remove the plaster, you will see the rebars. And this is another thing. Do not go for plastering of concrete. Most contractors will say that I will do it for free because it's easy for them to do it that way. But if you're a client, recommend not to go for plastering, because plastering is essentially done to camouflage or cover up all the mistakes. So what we should do is a concrete cover is required, not the plaster cover. Plaster cover is very permeable. It will not provide the adequate protection required. So you need really a concrete cover with whatever is the recommended. So please put in contract documents that no plastering allowed, especially in most of the exposed structures. Recommend for no plastering. And then they will put more time and effort on making sure that there is an adequate cover and the formwork will be also of good quality. These are the ways which we have to start working in tomorrow's construction. So we should, whatever is there, design on paper should be implemented at site also. And do not use a cover block which is made of brick or a plastic. There are a lot of cover blocks available in the market which is made of plastic and cheap, so or less expensive. So don't use that, because the plastic cover blocks, they don't bond well with the concrete, and it will provide an easy path for the chlorides, oxygen, water, etc. to reach the steel. So what you have to use is just a same concrete as that is used for the cover crate. Sorry, for the cover block. So also this picture on the left side, don't buy something like this, because this is so smooth surface. It may look very good for you, but it is not good for bonding well with the parent concrete. What you have to have is something like this, the center picture, where you see a rough surface for the cover block. So use the same concrete which you have at the site, just make some cover blocks like that on site itself. You can make with whatever the cover depth, or you make sure that it is having very good bond with the parent concrete. or the surrounding concrete. So don't go for a smooth surface. You need a rough surface for the cover blocks. Okay. And adopt less spacing here. Provide as much cover blocks as possible so that when you walk over this, because during the site practice, we will be walking on all these, and then you will see that many cover blocks are getting displaced, etc. So to prevent all that, tie them very well to the concrete cover and make sure that they are adequately provided. So what is the conclusion? Do TM ring test for all the TMT bars which you get, and determine chloride threshold, estimate service life, and that is the parameter we have to look at. And I also showed you a nomogram, which is like a one page where you can do some preliminary analysis of the service life. Okay, and then MXDY concrete is what we have to recommend, not just the M40, M30 like that. Start putting durability parameter onto that. And epoxy coated rebar should be used only if it is free of scratches and it is not allowed to expose to sunlight for about a month. Okay, so if you cannot do all this, don't use epoxy coated rebar. Protection measures, for durable life, we can go for surface coatings or cathodic protection system. And surface coating, if we are going, it should be done as early as possible. Otherwise, cathodic protection is the only or the currently available technology which is applicable or implementable on many of the structures. I think this is important slide for all the structural engineers. You should also think about how the materials behave. So arrest the corrosion first before you go for addressing a damage because of corrosion. Thank you. I think I'll stop here. This is our team in IIT Madras, large concrete research group, probably one of the best in India. So thank you.
Thanks a lot, Radhakrishnan sir.
Thank you, sir. Thank you. We can take the question, Satish.
Yes, sir. I'm just waiting. I think people are to give some questions. So in the meantime, Gautam Reddy sir has joined the webinar.
Oh, very good. That's great.
Good afternoon. Good afternoon, sir. Good afternoon to everyone, sir.
Good afternoon, sir.
Good afternoon.
There is a question from Venkatraman Parameshwaran. Satish?
Yes, I think it's an old question, sir. We have answered that, I believe. No, the recent question, it says, once steel got corroded, how to stop that corrosion?
Say again?
Once steel
got
corroded, how to stop that corrosion?
The one way is cathodic protection. This is if it has started corroding, then this is the only way probably. Because corrosion is essentially an electrochemical reaction. So what we do is cathodic protection, it gives current to the steel or electrons to the steel so that it compensates for it and it doesn't allow the steel to corrode, rather the zinc is the one which corrodes. So cathodic protection is essentially connecting a zinc metal to the rebar, and what it does is when there is a tendency for further corrosion, it doesn't allow steel to corrode, but the zinc starts corroding. So it's a sacrificial anode. Is that clear?
Oh.
Yes, sir.
Yes, sir. There's one more question.
And this is, we have a lot of structures where already we see corrosion or we don't see corrosion happening. It's hidden corrosion because we don't inspect the structures as often or as required. So any structure where there is a possibility of corrosion, cathodic protection is probably the most feasible technique available today to implement if you want to stop corrosion. But in India, we still, there's a lot more work to be done to, penetrate this technology into the market. Because long-term cathodic protection is best. And it's less expensive in the life cycle cost if you look at, in case of So the graph here is showing that. I can share this PPT with you, so you can share with the participants.
Yes, sure, sir. Thanks, sir. That would be grateful. So there's one question from Praveen. What is the corrosion rate threshold above which the durability of reinforced concrete structures impaired, or how to inspect the hidden corrosion?
How to inspect the hidden corrosion?
That's one question. There are two
how
questions.
To inspect
actually.
the hidden corrosion is there are electrochemical techniques like half cell potential mapping is found to be a good tool where you can, especially for pre-stressed concrete, we are seeing that it is sufficiently good enough to detect corrosion. Now, the first question was, I forgot. What was the first question?
What is the corrosion rate threshold above which the durability of reinforced concrete structures are impaired?
Yeah, so this is what you have to do for that. What you have to see is you have to do a test, and this threshold is different for different systems. So it's actually a combination effect which you have to look at. It's not only the threshold which you have to look at. You have to look at the combination of threshold, cover depth, which environment you are in, and also the type of concrete or the diffusion coefficient of the concrete. This combination effect is very, very important before we can decide on service life. So understand this nomogram, and that will help you to decide whether a particular reinforced concrete cross-section, like for example, if a cross-section let's say you take a steel concrete column, you put it in Chennai coast, and the same column you put it in Hyderabad, it may not corrode as early as it will corrode in Chennai, because the exposure condition has a significant impact. So you have to look at all this. So this nomogram does that job. So you can try this nomogram, and then that will help you to determine which type of structural cross-section combination is actually good for that particular exposure condition.
Okay, sir.
So
There's a
start
follow-up
thinking
question
about
from
this MXDY concrete. I'm telling in all my lectures that we have been talking, when you talk about concrete, the only one parameter we look at, FCK, and we end there. We start there and end there. This is the problem. When you talk about durability, we have to talk about M40 concrete. If you're saying that is fine, but also add D something. Durability or diffusion coefficient also should be defined before we go to the site. And the site engineers must ensure that the mix design which they use has a diffusion coefficient, it meets the target diffusion coefficient. I know it's a little bit complicated, but that's why I'm sharing this slide. So if you have any doubt about these things, you can feel free to email me. I'll be more than happy to clarify these things. And my email ID I gave in the last slide.
Okay, sir.
So you can note this down, pillai@iitm.ac.in. We'll be more than happy to give clarifications. I think I took 1 hour now, so let's probably go to Professor Haji.
So the one more question there's one question I would like to bring it out, sir. So it's from Sharana Kumar. What is the minimum curing period of a concrete?
Minimum curing period?
Yeah.
As a scientist or something, I would say 28 days for OPC and more than that for 56 for fly ash or slag-based systems. But I know it is not really practical. So what I would suggest is we go for 7 days for OPC-based concrete in the field. If you're talking about any system with fly ash or slag or any of those SCMs, we should go for at least 14 days.
Okay. Okay.
And there is a problem when I say 14 days, anyway, site managers will come and say that, no, I want to remove my formwork on 7th day or something like that. But you have to think, you are talking about building something for 50, 60 years. Spend 1 extra week, give that thing some time to cure. It's like this, if you're making a, let's say a payasam or some dish, or carrot halwa, for example. You need time for that material to cook. You cannot make gajar ka halwa in 1 minute. It's not going to happen. And I will pick this classic example, which I'm quoting Professor Sudhir Misra from IIT Kanpur. He mentioned this in one of the ICI lecture. So, there is always this tendency for, everything I want yesterday. So the example he quoted was, बच्चा पैदा करने के लिए 9 महीना लगता है, right? To deliver a baby, it takes 9 months. So you cannot, every time you cannot say that I cannot wait for 7 days, 7 more days. You have to work around the system, and construction managers have to respect the time required by the fly ash system or slag system to be able to, mature. Then only we will be able to exploit the properties. Otherwise, on paper, everything will be there, but on site and a real structure, it will not materialize. I mean, you will not realize. So if you want to really exploit the full potential of the material, we have to give enough time for that material to cure properly. So take the formwork, that is fine, but make sure that enough water is given to the structure. But then for taking the formwork, you have to look at the 7-day strength. Otherwise, I've seen structures where they remove the formwork early and then flexural cracks are there. And then they cover up the flexural crack with plastering. This is why I mentioned that don't allow plastering. Because plastering is a problem.
Okay. Any other questions, Satish?
So one last question, which is plastic cover blocks are widely used outside in high-rise shear wall structures.
Yes.
For Mivan formwork. Does this issue need to be addressed?
Yes, it should not be used.
Okay.
It should not be used because, see, imagine I see what these circular cover blocks, which you will see in many sites. What happens is that thin wheel type cover blocks or any plastic material, when the concrete starts shrinking, or over a period of time, there will be a fine gap formed between the plastic and the concrete. It will get debonded. And once that happens, your oxygen, moisture, chloride, all these will go very fast. You don't need any more diffusion process. The diffusion coefficient of chloride doesn't play a further role after that. It's very fast and you will have localized attack. So I suggest to go for concrete itself. Just make concrete blocks. Instead of plastic, we can even go for thin discs of concrete made out of concrete. And you can, today you can have polymers and all that. Lot of the materials are there, which can be ductile enough in such cases also, so that they don't break very easily. So technology is available. We have to just come up with these new things. Maybe all the cover block manufacturers who are making out of plastic, they should probably think about how to use concrete itself to make the cover block, or how to use concrete cover blocks. Sorry,
I think
how to use concrete for making cover blocks. Sorry. Yeah.
I think I left just one question, sir. Yeah. Hello?
Yes. Satish, go ahead.
One last question, sir. Is the corrosion is the main reason for cracking?
I will not say main reason. It depends on the structure you are talking about. There are many ways by which a structure can crack. Right? So it can be because of shrinkage, it can be because of corrosion, it can be because of any deterioration process, and it can also be because of structural problems.
Okay. So corrosion
not
is not the
necessarily
only
material problem. Not necessarily corrosion or other concrete deterioration problems or shrinkage problem, but it can be structural problem also. Inadequate design, then also you will see cracking.
Okay, sir.
Okay. Okay.
Okay.
Thank you, Dr. Radhakrishna Pillai, for your
Thank you
illuminating
very much.
lecture. Thank you. And I hope most of the doubts that the participants may be having have been dispelled by your illuminating lecture. Thank you very much.
Thank you.
Thank you. So now we will go to the last session by Dr. Haji Sheik Mohammed. So I think he is coming out with a remedy for Mr. Dr. Radhakrishnan Pillai's problem.
Good
So,
afternoon to all
Doctor-
of you. I am audible.
Yeah,
Yes,
you
sir,
are
we can hear
audible.
you.
Able to see my screen?
Yeah.
Very
you are
much,
able
sir.
to-
Okay.
So Dr. Haji Sheik Mohammed is Professor of Civil Engineering in Abdur Rahman Crescent Institute of Science and Technology, as well as he is the Dean of Academic Affairs. He is going to deliver a lecture on performance of galvanized steel rebars for use in concrete construction. Dr. Haji Sheik Mohammed, you can take the session.
Thank you, sir. In the name of God, the most beneficent and the most merciful, first I want to thank the management, iSteel, my professor, Dr. Santha Kumar, sir, and my mentor, Dr. Radhakrishna Pillai, for this opportunity. Topic is performance of galvanized steel rebars for use in concrete construction. Myself, MS Haji Sheik Mohammed. Along with me, Ms. V. Rupa, Assistant Professor, my Ph.D. scholar. Overview of the presentation is galvanized rebars, introduction, production mechanism, manufacturing process, performance evaluation. Here I want to show some test results already conducted on the galvanized rebar with respect to chemical resistant properties and mechanical properties. And finally, I will give some resultant discussion and conclusion. Actually, Dr. Radhakrishna Pillai, sir, did an elaborate discussion on the various causes of corrosion. So a client using the rusted rebar initially without knowing the consequence, once rust started, he is a bit worried. Once crack happens, he is worried about the loss or the money he has to spend on repairs. So this cartoon shows the consequence of corrosion and the economy involved in it. Actually, galvanizing is a protective coating for corrosion control of steel bars in concrete environment. Dr. Pillai enhancively covered the various drawbacks and lacunas in the non-metallic coatings. This is galvanization is a metallic coating. Hard dip galvanized coatings have been used around the world over 50 years. Not now we are using. It is a existence in the world. It's a factory-oriented process, normally applicable for major projects. Implemented already in the different parts of the globe. Some of the projects like deep tunnel sewage system in Singapore during 2008, a new Watford boat, Bermuda 83, Boca Chica Bridge, US 1972. Even in India, in Delhi, they have constructed a Lotus Temple using galvanized rebars, 1986. Still, that structure is fine without any deterioration. And Parliament House in Australia was also constructed using galvanized rebars in the year 1988. This picture shows the view of galvanized rebar in the typical site conditions. Before understanding, actually, Dr. Pillai gave an overview of the cathodic protection. I will make it very, very simple. Actually, we have to understand a very simple concept, bimetallic corrosion. If two metals are connected to each other, the less inferior material will corrode, metal will corrode to protect the more noble material. So based on this logic only, galvanized rebars are working on this concept only. Here you can see that both the nuts were done on the same time, but comparing to the nut on the left side, the right one is inferior material. So this nut got corroded by protecting the other noble material. Here again one example. Here comparing to the bolt, nut is made of a noble material, so nothing happened to the nut, bolt and other things got corroded. So everything depends upon its status in the electrochemical series. You can see this, don't worry about this listing. At least we can see that comparing to iron, zinc is the less noble material. So in that list, after the iron only we have zinc. So comparing to iron, steel, zinc is the less noble material. We are advantageously using this zinc for the protection of the steel. That's that's a logic only the cathodic protection works. So in this case, if we connect steel and zinc, if an environment is favorable for corrosion, zinc corrodes by protecting the steel. Corrosion protection mechanism, galvanized coating. Actually, you are seeing a rebar. Over that, it's a some picture. Over that, galvanized coating is there. The advantage here is if we apply hard dip galvanized coating, in this intersection, some steel zinc alloy is formed. Some metallurgical reaction takes place between steel and zinc, then formation of coating made up of series of iron zinc alloys at the interface. Outer layer of the hard dip galvanizing is a pure zinc. So what I'm willing to convey here is some metallic bond is created, not a superficial bond. Moreover, the strength of this bond, actually the hardness, toughness of this composite is more stronger than the steel. Somebody may ask, somebody may got some doubt. Steel is also corroding. Because of that corrosion, there is some volume increase is happening around the, there is some rust deposition over the steel rebar. Because of that, there is some volume increase. This volume increase created a pressure around the, pressure to the concrete around the steel rebar. If the pressure created is more than the tensile strength of the concrete, then concrete will leave away. Here also somebody may got a doubt that here also zinc is corroding. Then here also there is a volume changes involved. Then this also will lead to cracking or not. Like that somebody may got a doubt. But here the advantage is the zinc corrosion products are very loose and powdery materials and less voluminous than iron corrosion products. Moreover, once zinc corrosion takes place, this in this picture you can clearly see that the loose zinc material go and penetrate inside the concrete. Even some researchers, they have proved that this loose zinc material closes the pores in the small pores in the concrete. So moreover, one big advantage is corrosion rate of zinc in concrete is lower than steel. Dr. Pillai sir explained about carbonation and chloride ion. In both the aspects, in carbonation and chloride penetration, zinc is more advantageous. In the when the steel rebar is kept inside the concrete, it is concrete is highly alkaline, 12 to 12.5. So if corrosion condition is favorable due to carbonation, then there is a reduction in pH. Once the pH is come down to from 12 to 9 to 9.5, then steel will start corrosion. But here the zinc, if we apply the galvanization over this, even up to 6.5 pH, the carbonation related problem will not be there. Moreover, the threshold, chloride threshold value of the zinc is more than the steel. That's also over two ways, even in the carbonation front and in the chloride front, both ways this is advantageous. This is the typical galvanization process done in a factory. It's a factory process. So rusted rebar, the rust removal is done by acid pickling. Acid pickling is nothing but a diluted hydrochloric acid solution. In that some inhibitor will be added. Otherwise base metal will get attacked. So that's HCl, water plus some inhibitor solution. So if we dip the rusted rebar within 10-15 minutes, depending upon the intensity of the rust will get removed. After that, the acid neutralization is done by cleaning with water. Then the process is immersion in flux solution. It contains zinc chloride and ammonium chloride. Then the rust-free rebar is immersed in molten zinc at 450 degrees centigrade. Then followed by quenching in sodium dichromate solution. So coating thickness will be formed is around 100 plus or minus 25 microns. Moreover, coating thickness, we can have a control depending upon the protection expected. Even we can give the more thickness or less thickness depending upon the environmental exposure. The treatment duration normally within 2 hours, you can complete this process. This is a typical arrangement in the factory, corroded rebar and immersed in a pickling solution. So rust-free rebar, rust removal, actually the acid removal is done by immersion in the alkaline water, followed by dipping in the molten zinc bath at 450 degrees, followed by quenching in the sodium dichromate solution, then coated rebars. What is the advantage of galvanized rebars? As I have mentioned, zinc possesses higher chloride threshold concentration, 2 to 4 times more than the bare steel, so that it delays corrosion initiation. Dr. Pillai again emphasized that the corrosion, you have to lengthen the corrosion initiation period. On that way, the galvanization will be helpful. Moreover, zinc has much greater pH passivation. In the carbonation level, up to 6.5, no problem. Moreover, sacrificial protection to steel. Even as mentioned, we cannot handle the coated rebars like flavors in the site. So it is expected for a rough handling and dragging everything. So here, since it is a sacrificial type of coating, if any break in the coating happens also, the zinc surround the damage will preferentially corrode and protect the exposed steel. Moreover, this bond is metallurgical bond, so cannot be broke down using some impact and other things. So it improves the adhesion. Iron zinc alloy layers are harder than the substrate steel. So it is like a metal. So no need to worry that some coating we have applied. And no special precautions during handling, transportation and placement at job. But normal procedure we have to follow for stacking and other things. Moreover, we have to see to it we are not damaging too much to the zinc, although it is a sacrificial. Still, we have to take care of the basic stacking arrangements and other things. A very, very big advantage in the galvanized rebar is the bond strength development with the concrete is similar to the uncoated rebar. Some coating may be a greater corrosion resistant properties, but in the bond aspect, according to civil engineering, we are more worried about the bond strength development between steel and concrete. If there is any decrease in the bond, again, it will lead to some problem. So here the main advantage is there is no bond strength reduction because of this metallic coating. Now I'll present to you quickly some performance evaluation tests, some of the tests carried out with respect to corrosion resistant properties and mechanical properties. 3 corrosion resistant properties aspect, 3 test results I'll be presenting here. Chemical resistance test, open circuit potential test and macro cell test results. In the mechanical properties aspects, I'll be covering bond strength to concrete test, impact test and adhesion test. Chemical resistant test, it is like a immersion in a chemical medium, and the medium considered for this test is distilled water, 3 molality calcium chloride and saturated calcium hydroxide solution. This test was carried out as per IS 13620 and ASTM A775. So even according to this test, we have to create some intentional damage in the coated rebars to study the effect of the damage on the coating material. So in the vapor phase, how it behaves, and liquid phase, how it behaves, like that we have to observe for 45 days. Test duration is 45 days. These are some of the specimens after 45 days exposure. You can clearly see that in the 3 molality calcium chloride is a very, very tough medium. Any good coating definitely will corrode in this medium. Even in this medium, nothing happened. There is some minor dissolution of zinc and no steel corrosion. That's very, very important. Even in this tough chemical environment, see to it zinc corrodes preferentially and not allowed the steel to corrode. In the 3 molality sodium hydroxide, it is like a concrete environment, alkaline environment. Not much happened. The things are fine. In the distilled water, sorry, this one is saturated calcium hydroxide, not sodium hydroxide. Saturated calcium hydroxide, it's again a concrete environment. Even in the distilled water, the water we are seeing that it's a less inferior medium like that, but water is a great affinity to create corrosion. Even in the water immersion at 45 days, not even, there is a slight dissolution of zinc was observed. There is no major change in the properties of the steel rebars. Ultimately, in the in the extreme right, you are seeing a picture showing the immersion test setup. The uncoated bars were immersed. You can see the severity of the corrosion happened. So comparing to this and this, you can see the major variation in a major difference in corrosion resistance because of the galvanization. These are the typical observations we got after 45 days in the distilled water medium, and no corrosion products of iron. Some mild softening of the coating happened and dissolution of zinc in all the tested mediums. In the liquid phase and in the vapor phase, there is no corrosion products of iron or steel. In the drilled specimens, I have told it to you, we have to make some intentional damage to study the effect of a coating damage on the properties in the chemical immersion test. Again, we have seen that there is no undercutting formation around the intentionally made holes, and it's like a normal rebar. It behaved. It's really good. In the liquid medium, we have seen the performance of this galvanized rebar. Another one is in the concrete medium, how this galvanized rebar behaves. One test method is open circuit potential test. It is a qualitative test carried out as per ASTM C876. A test setup contains coated rebar is placed inside a concrete specimen with a specified cover 20 mm or 25 mm, and the electrical connection was taken out. So these specimens were after casting, after curing, subjected to alternate wetting and drying for actually for 1 year, around 1 year, alternate wetting and drying. It was subjected to in the 3% sodium chloride solution. At the end of every wet cycle, dry cycle, the potential development or the corrosion condition inside the specimen was monitored. This is a typical schematic of the test setup. This is the specimen. You are seeing a concrete cylinder inside. We are seeing a steel rebar. So because of the chloride ingress, definitely it will try the zinc will try to, or any coating will try, it will affect the coating material, and accordingly there will be some electron release. These electrodes will capture the electrons released due to the corrosion, and accordingly it will show a potential value when we connect it to the multimeter. So normally you can use any electrodes. In this test, I have used saturated calomel electrode. Don't worry about this table. Finally, what I want to emphasize is, if the potential developed is greater than 126 to 276, this is for a normal steel, not galvanized, normal steel, then the steel is under intermediate corrosion. If the potential developed in this test is greater than minus 276 millivolts, then the steel is under less than greater than 90% risk of corrosion. If the potential developed is minus 400 and above, then it's lead to it qualitatively we can infer that the rebar is under severe corrosion. Now you are seeing the behavior of the various coated rebars in the open circuit potential test. Now for our discussion sake, we will concentrate only on the brown color curve and blue color curve. The brown color curve is the curve for the uncoated rebar. Uncoated rebar, from the earlier table, we have seen that once it crosses 250, it is under severe corrosion. At the end of 1 year, the potential developed is around 500, minus 500 millivolts. That means the rebars, the uncoated rebars are under severe corrosion. In the case of galvanized rebars, here galvanized, once the chloride goes in, the zinc preferentially corrodes, and accordingly there is a potential increment. We have to mind it here that this increase in potential is not due to corrosion of steel, due to corrosion of zinc. So the zinc protected the steel rebar throughout the year. Even at the end of the 1 year, the potential developed is minus 500. So this potential will keep on protect the steel rebar. Once this potential reaches 250, then only the steel corrosion can initiate. For that, we need lots and lots of years to reach that level. So what we have to infer here is uncoated bar under severe chloride exposure conditions are very vulnerable to corrosion even within the short 1 year period, whereas the galvanized rebars is giving a longer protection. So at the end of the 1 year, the specimens were broke open to see the condition of the rebar inside. So what we observed is there is in the uncoated rebar a patchy rusted area with few visible corrosion pits. Even in that 1 year period, some pits were visible. The interpretation is the severe corrosion risk. Whereas in the galvanized rebar, some zinc oxide patches were observed, indicating only dissolution of zinc. That means zinc preferentially corrodes and protects the steel rebar. Because of that, some patches of zinc oxide was observed. There is no corrosion products of iron. So the interpretation here is it is under very low corrosion risk. This is one other test depicting the marine conditions. So this is the typical test assembly. RCC prism with the top rebar and the bottom rebar. This is not the galvanized rebar, but for just to explain, I have made this. And we have to actually some tanks were provided over the specimen. In this tank, chloride solution will be sent in. This chloride will go in and affect the top rebar. So once it affects the top rebar will get corroded. Accordingly, that will act as an anode. The bottom rebar will act as a cathode. An electrochemical cell create between the top and bottom rebar, so that accordingly, this is typically a marine environment exposure condition. In the marine environment, the rebar near to the cover only getting affected or damaged heavily. That was depicted in this test of ASTM G109. So here also, this specimen was subjected to alternate wetting and drying for 10 days. At every wetting and drying, the potential in the top rebar was observed. Even the current development between the top rebar and bottom rebar was observed. Don't worry about the thing. Macrocell, this is the graph between macrocell current development with respect to time. So here, once again, we have to give our emphasis on two things: uncoated rebar with brown color curve and the galvanized rebar with green color curve. Uncoated rebar, you can see that upon chloride exposure, there is a steep increase in current within the shorter period. Even you can see that within 1 or 2 months, there is a steep increase in current. That means it started corroding heavily. And at the end of the 1 year, the corrosion current development is more than 100 milliamps. This shows that the rebar is severely corroded inside the concrete specimen. Whereas in the galvanization, you can see that upon exposure to chloride, this increase in current, again, I want to emphasize here, this increase in current is not due to steel corrosion, corrosion of zinc. So the corrosion preferentially, zinc preferentially corroded. Because of that, there is some current development. So throughout the year, it see to it, the steel rebar is not getting affected. This also again a classic example how the galvanized rebar works inside the concrete medium. Again, I come to the bond strength. Some of the attendees have given a comment in the chat. Corrosion is like a fracture in the body bone, like that. So here also I want to emphasize that. It's a RCC means in an analogy wise, we can consider RCC as a skeleton and muscles, combining skeleton and muscle. So the bond strength development or the composite action of the steel and concrete is very, very vital for the successful or expected performance of the RCC members, what we are designing. Suppose the steel rebar is like this before concreting, then what is the problem? So here, if I concrete this area with the corrosion, so what will happen? My concrete will not be attached to the parent steel. Only concrete is attached to the rust. So due to other deleterious environments like carbonation and chloride, again in this interface, rust develops, volume increase. So what will happen? There won't be any bond exist between the steel and concrete. So in addition to these corrosion protection methodologies, in addition to the extension of service life, it also giving a value addition to the structural design. So suppose you consider if there is a no bond exist in the interface during earthquake times, what will happen? So it is very, very essential that we have to go for some corrosion protection methodologies. As rightly mentioned by Dr. Pillai, if you are going for a coating, non-metallic coating, you have to be very, very careful. And cement-based coatings are better. Otherwise, you have to go for these galvanized rebars. So this is very, very important. Unnecessarily, because of corrosion, we are introducing one unnecessary layer. So whatever the quality concrete we put, actually there will be definitely there will be a problem in the interface. So to study the bond strength development, some cube specimens were casted as per Indian standard 27708 1967. So galvanized rebar centrally embedded in a cube, and all the test methods, everything happened according to the Indian standards. So this is a typical test arrangement. Don't worry about the arrangement. This was a special hanging arrangement was made, and even this hanging arrangement was made as per Indian standards. And specimens were upside down. It was kept in the UTM, and the extended portion of the rebar was holded in the bottom wedges, and the hanging assembly was made to move up so that a pull out actually we have created a situation that the rod is pulled out from the concrete. So as rightly mentioned by my professor, the load slip behavior is very, very important. Moreover, load at 0.025 mm free end slip and 0.25 mm free end slip is very, very important. In addition to the ultimate failure load and type of failures. One thing we have to remind here that in coated rebars, the fusion bonded epoxy coating and other in the coated rebars, a 20% loss in bond strength the coats are permitting, but real time scenario is many of the research laboratories they have reported that more than 20%. This is a typical load slip behavior. Don't worry about the things. It is between load and slip. Now, here also we have to worry about the curve, a brown color curve and green color. Here you can see that the load slip behavior of the brown color curve and green color curve is almost similar. That means that the earlier statement which I have made, there is no reduction in bond strength, which is a very, very important structural aspect. It's not getting disturbed because of this metallic coating. Here again, you can see some values as a values in the uncoated rebars. Bond strength at 0.025 mm free and slip is 10.93 MPa. For galvanization, 10.59, almost similar. Again, bond strength at 0.25 mm, almost similar. So we got 97% of the bond strength of the uncoated rebar, almost a similar bond strength development. This is really good. Another test in the impact test in the site, we know that we cannot handle the coated rebars like flavors. So this test will give you an indication whether the coating, metallic coating, if it experiences the impact, how it behaves. So this test was conducted as per ASTM G14. So the coated rebars were subjected to 9 Newton meter impact. So the test criteria is, because of this impact, there shall not be no shattering or cracking or bond loss can occur except at the impact area. In the impact area, there can be some damage, but because of this impact in the neighboring areas, there should not be any damage. That should be that's the condition of the test. Here we have did the test according to the ASTM. We have found that other cement coated bars and other coated bars in the impact area, severe damage was observed, but it's permitted according to the code. In the galvanized rebar, very minimal damage was observed in the impact region. Adhesion test, actually the coated rebars, actually cutting and bending we have to do. Whether for cutting and bending, this type of how this coating will, the galvanization behave in the cutting and bending process. So this test was conducted according to ASTM A775. In this test, the coated rebars were bent over a bar bending table of with 150 diameter mandrel at 180 degrees. The test requirement is, because of this bending, no cracking of the coating shall be visible to the naked eye on the outside radius. Inside radius, there can be any, there can be damage, but outside radius, there should not be any damage. So these pictures clearly show, even after bending, we have not seen any disturbance in the coating. Whereas in the other coatings, coating material lost its bond. That means this coating has to be applied after cutting and bending operation is over. I'll show you one video. I'm showing you once again. I think it was a very quick one, and able to see the video?
Sir, we could not see the video.
Okay. I think I have not shared it properly. Okay, I'll do that again. It's a very, very important video. I thought of.
Okay, sir.
Okay. Able to see now?
Yeah, now we can see, sir. Yeah.
Once more, I'll do. So coating flexibility, adhesion, no issues with the galvanized rebar. Somehow one case study I will explain. With that I will wind up. Actually, this field case study from artisanal fishing pier expansion. The objective is the pier expansion work was carried out at a greater depth for ships. The design life of this structure is 25 years. The construction was carried out during the period 2001 to 2003. Structure-wise, steel piles they have used, and the RCC longitudinal transverse beams and RCC deck was the design. They used M30 grade concrete and galvanized steel rebars. Dry film thickness of the galvanized coating is 86 microns. This is the pier image taken in a photo during 2009. So constructed in 2003. This is a picture of 2009. So in the 2010, earthquake happened in that zone, and the bridge was severely damaged. So when the galvanized rebars were inspected, so you can, by surprise, they have noticed that there is no steel corrosion. There is no steel corrosion. Only there is some formation of zinc oxide. That means in this extreme severe marine exposure conditions, the galvanization able to, the zinc able to sacrifice and protect these rebars from deterioration, and there is no steel corrosion was observed. Moreover, bond also they felt that it's really good. So there is no signs of steel rebar corrosion even after 7 years or 9 years of its initial starting of the construction. As Dr. Pillai rightly told, you have to concentrate on both steel properties and concrete cover. Balanced approaches required. If you take care of steel and leave the concrete, again it's a problem. Take care of concrete, leave the steel, again it's a problem. So their synergistic effects need to be considered for the long-term durable service life of the structures. Conclusion here is the galvanized rebars offers excellent chemical resistant properties, and in both the tests conducted in the concrete environment, it shows that low corrosion risk. The macrocell corrosion test results showed improved sacrificial protection. There is no problem with the bond strength development with concrete, almost as similar as compared to the uncoated rebar. Impact and adhesion test result shows promising results and satisfy the Codal requirements. Some thoughts. Galvanized rebars are emerging as a promising approach for corrosion prevention in RCC structure, in particular major infrastructure projects, by considering the defective nature of the non-metallic coatings. And this may come as an emerging and promising material or promising technology in the future for corrosion prevention. Corrosion protection efficacy of the galvanized rebars depends on the thickness of the coating and exposure conditions. So even we can design, what I'm willing to say is even steel manufacturing companies can design in such a way that the thickness of the coating can be fixed depending upon the exposure conditions. Accordingly, they can have some economy. Cost saving approach they can suggest to their clients. Compatibility of the zinc with admixtures. Nowadays, we are using many admixtures in the concrete, superplasticizer, corrosion inhibitors, and other things. So this study need to be done in detail. So I understand IIT Madras is doing extensive studies, and we are also a part of it. So we are jointly doing some experiments to study this, the compatibility of the zinc with the admixtures commonly used nowadays. The challenge of production of galvanized rebars for use in small projects. Actually, for the larger projects involving hundreds of tons, you can have it's worth to do the galvanizing coating as an online coating. But in the small projects, how you are going to handle, it's a challenge for the steel manufacturing companies. Moreover, steel manufacturing companies shall explore the possibility that it should be done in an online continuous process. Once manufacturing, then again do all the process, it will be difficult in the long run. Moreover, there will be a cost saving also if you do it in an online in a single stroke as one of the component of the steel manufacturing process. So if you come out with this type of technology at an affordable cost and satisfying the compatibility conditions with the conventional and modern construction chemicals used nowadays in concrete, it's nothing like it that this technology may emerge as in a greater way in offering a corrosion prevention solution for the RCC structures, and this will enhance the economy of our country even. I think Pillai sir not mentioned to mention, India is losing more than 2 lakh crores of rupees as a corrosion loss due to corrosion. So we can contribute to the economy of the country if you do come out with some innovative technologies. Thank you very much. I'm done. Thank you very much.
Thanks a lot,
Dr.
sir.
Haji.
Yes, sir. Thank you. Any question I can answer, or my mentor, Dr. Pillai, can answer. If any questions, we are happy to answer.
Yes, sir. There's a question from Mr. Praveen again. Normally, ordinary rebars form a passive oxide layer while concreting or after concrete the structure, but galvanized rebars forming that layer.
Actually, the ordinary rebar, even if the rebar is corrosion free only, that passivation layer forms. If you immerse or if you use the rusted rebar in the science, actually the research studies prove that there is no passivation layer. Here, zinc and cement hydrate, some layer will be formed.
Okay. Okay.
Dr. Haji,
yes, sir.
No, one question from me. Hello.
Please. I'm hearing you.
Despite many advantages that you have highlighted about hot dip galvanized rebar, why it is not promoted as it should be? Why it is not recommended by the architects or the structural engineers?
Actually,
with a lot of deficiency, still people prefer only FB fusion bonded epoxy coating.
Actually, the awareness level is one problem. In UK and Canada, they are using in an extensive way the galvanized rebars. Moreover, here in our country, Dr. Pillai used to tell always, we are bounded with codal provisions. We have not come out with a unique code for this. That also may be a reason. I think Dr. Pillai can add on this.
I join Haji in basically, I think it's an awareness problem. Okay. And also the cost is high about galvanized steel. I think you are best person to answer that, Subramanian sir.
Question is written to you.
No.
I think cost is the main reason.
Correct.
And we don't have a habit of looking at life cycle cost. We are always attached with the initial cost. Maybe Professor Santha Kumar, if can say, he will be better.
Yeah, actually,
maybe life cycle cost we don't talk at all.
Yeah. Life cycle cost will definitely be advantageous for galvanized steel. But one main reason is if I specify today galvanized steel, who will supply?
Correct.
That is the major
That is why I was telling Subramanian sir to answer. We have to get it into the market.
It is a right direction in which we are moving to encourage galvanized steel. But before it can be implemented for major projects, it's okay. But for minor projects, unless steel companies come out with alternative of galvanized steel made in factory and made available to the user, the structural engineers cannot specify.
Correct. I do strongly agree with Professor. Unless we are ready, we cannot offer the solution to the society and country. We should be ready first.
At least maybe we can start off a pilot project somewhere, identify a project where we can, show it as a pilot study.
And simultaneously, we have to strengthen the codal provision from Indian standards.
Yes.
Yes, sir.
Because any government project, they will not agree unless there is a
correct.
Codal provision. That is there.
So there's one more question from Mr. Mohammed Sabit. He is asking, are there any codes being prepared regarding the usage of galvanized steel rebar?
Actually, galvanized rebars, some codes are available, but that code specifies that how to coat, what should be the thickness, what should be the zinc content. They not very specifically about refer about the RCC applications and what are the do's and don'ts. It's not specifying.
Okay.
That's the problem.
Code is there. Code is
very generic codal reference.
Yes, very
it is a generic code. You can refer IS 12594.
What is that code on? I don't know about this. What is that?
It is giving only the manufacturing process and the coating thickness.
IS 4826 hard dip galvanized coating on round steel wires. And ASTM also we have ASTM A767. It again the steels for the concrete reinforcement. Again in that code they are saying about how the zinc content should be and how it should be applied and how it should be taken care of in the field conditions.
But unless it is recommended or suggested in 456, it will be very difficult.
Yes, correct. Yes. I do strongly agree.
No, that is where institutions like IIT and Abdur Rahman, Crescent Institute of Technology should come forward. You have to pressurize the Bureau of Indian Standards to include that one. Then only you can give confidence in the minds of the manufacturer, because manufacturer will also be very, by having all the facilities available. If there is no market, if there is no recommendation from the architects or the structural engineers, then the entire investment will be a waste, no?
I think actually Dr. Pillai answered this. Industry should come forward and give some project. Then only we will get motivated and
unless and until, for specific projects, some recommendation should come from these bodies, government bodies.
Actually, sir,
I agree. For government projects, I agree with what you say. No, we will work on 456. I'm not saying that is not, but that will take time. But in the meantime, can we actually identify some projects? I mean, there are 42 participants here, and I'm sure they are also, some level of decision-making powers. Maybe some projects, if we can identify, can steel companies provide galvanized steel?
So if I may be allowed to answer that question, Subramanian, sorry to interrupt.
Thank you. Thank you.
So as a company, we are committed to give the best product, and we can supply galvanized steel bars. That is not a problem, right? If there is demand from the market, it's a very short span, we will be in a position to supply galvanized steel bars, right? We have already made a strategy. So from our side, we are completely ready, and we'll be willing to even supply for a smaller lot also, no problems.
So maybe we can talk to the big industry players to identify some project where government norms are not, means constraints, private projects even, which is on the coastal belt. That will be perfect.
Yeah, that's a great suggestion, sir.
We can talk to many of the, like if you go on the ECR, there are so many projects going on. We can suggest probably one of the builders over there to use this. And from our side, we can help in giving the technical confidence.
Yes, sir.
Moreover, cost also, I request industry to see to it it's feasible. Actually, some money elastic, inelastic customers, no issues.
Yes.
But in a major level, if you are taking it through, means cost should be.
That is main. Now I think it is 2 times, right? How much?
I think, according to my judgment, more than 15,000 rupees you have to spend, I think, for 1 ton. I'm correct, sir?
Yes, sir. You're absolutely right.
Correct.
You're absolutely right, sir.
So instead of 45 to 50, it will be 65, something.
Yes, sir.
Even then, according to me, it's cheap. In the one house, we are going to purchase only 3-4 tons of steel in a small house.
Yes. So
Still, but mindset of the people.
No, I think what we have to talk in a way is that instead of looking at the percent increase in the cost of the rebar, we should talk about percent increase in the cost of the project.
Then it will be very cheap, very less, very.
It will be nothing, almost negligible, and also bring in the life cycle cost. So these two aspects, if we bring in, I think it will be sellable. People will buy the idea, I think.
Absolutely, sir.
Okay,
and the life cycle cost is more relevant.
Maybe Haji can include these two aspects in the next paper.
Yes.
especially if we have to extend the life without repair.
Yes.
Correct.
In a regular bar, you also need repairs and rehabilitation.
Yes.
Repairs and rehabilitation will be much less in galvanized situation. So life cycle cost, repair and rehabilitation.
Correct.
If you take all this into account, we should be able to convince people.
Yes.
Yeah.
Dr. Haji, what is the status now? Is it still in the infant stage, or are we selling any HDG bars in India?
I think
Sir, you will know more than us, sir.
Correct.
No. That is why, as my MD told you,
I don't know.
We are ready with the strategy, but we would like to know, as it started moving, it has got any.
No, sir. I think we have to do a concerted effort here. Talk to some, structural consultants who are working on some project along the coast, near the seashore, and just convince, and we can help in talking and all that, and convince them to use on one structure, use this bar.
Moreover, the performance.
Or if not one full structure, we can even say, if you have 10 columns in the structure, let's say you put galvanized rebar on 5 of them.
Moreover, sir, one thing, in the performance against atmospheric exposure, really wonderful. Even I have specimens of 10 years old specimens, galvanized after 10 years. Even if you are looking for exporting steel to Sri Lanka or another country, this should be very viable. Nothing will happen. You can give the steel as such.
Fantastic. Thank you, sir. I think all these suggestions, I think from the company side, we'll make a more concerted effort, and we'll make sure that we reach out to at least a few builders and structural engineers in the coastal areas.
Yeah, that I think we have to make up, some kind of actionable items we have to write down and then move on.
Yes. I think from our side, we'll definitely do that, and we'll also reach out to you for your expertise. Thank you.
Yes.
I want to conclude. I felt very happy to present before my professor, Dr. A.R Santha Kumar, sir. I request your blessings and wishes always.
My blessings are there always with you.
Thank you, sir.
Thank you, Dr. Haji, for an inspiring lecture.
Thank you, sir.
And I think all the participants would have taken note of your valuable points. And definitely we'll move in the right direction. As my MD told you, yes, we are keeping a strategy. Yes, we will work out, and we will take the support of you and Dr. Radhakrishna Pillai.
Pillai and me.
Pillai and me. You are going together.
Both together.
Okay, whatever it is. Okay.
He is my mentor, actually.
Nothing. We are friends. We are good friends working together. That's all.
Yes,
okay, we will go with the mentor as well as disciple. Okay, no problem.
Okay. Mentor is sitting on the top left.
Yes, sir.
Mentor means you don't have any much scope, no?
No. Working mentor.
Working man. Okay, thank you very much once again, Dr. Haji.
It's good that, and unless we collaborate with industry, not only the construction part but also the manufacturers, and I think that is the best or a healthy,
And to also add, sir, we will try and personally, I will try and rope in 1 or 2 other manufacturers also.
Yeah.
I will try and sell them this concept and see if I can get in 1 or 2 other manufacturers.
Sir, if we want, we can also have a close discussion with those manufacturers like this. 1 hour meeting. I mean, it's
Yes, sir.
Yeah, we can do that.
So that it will also be good that the customer has a choice to go to two manufacturers, 3 manufacturers for his requirement. That will also build confidence in the customer. So we'll definitely do that also.
Yeah. Yeah, that I think will be good.
Yes.
So maybe we can plan a meeting with multiple manufacturers, and we can make this same presentation so that they can also, get confidence.
Absolutely.
And not a larger group, just to, and then maybe I can also try to bring somebody from L&T, Dr. Shiva, or somebody who specifies in L&T also, or some design officers. Not necessarily L&T, design officers will. We'll invite people for the meeting. Maybe.
Definitely, sir. Definitely, we'll do that.
Some 10 to 15 people, if we get, I think that will help.
Yeah, definitely.
Okay, sir. Okay. Thank you.
Thank you all. Thank you very much.
Thank you also.
Thank you, everyone.
And I request Mr. to give a vote of thanks, please.
So, okay, now we have come to the last stage of proposing a vote of thanks. First of all, let me.
Sir, you also come on stage. We will take a snapshot.
Okay.
Switch on your camera, sir.
Dr. Senthil is here or no?
No, sir. He left us.
I think there is a way to just click somewhere. It will take a snapshot, I think.
Am I visible now?
Yes, sir.
Yeah.
So first of all, let me thank my management, iSteel management, and my managing director for giving me an opportunity for sponsoring this webinar for the benefit of these site supervisors and field engineers. Thank you very much, sir. Let me also thank the guest speakers for making their presentation very, very fascinating and informative. I suppose that all the participants would have made use of it and as far as possible try to implement in their daily life. I also thank the participants, I think numbering 42 people, for their involvement and interactive participation. Finally, I thank my colleague Satish Kumar for providing technical assistance to make it possible.
Thank you, sir.
A fully recorded version of this webinar will be made available in our YouTube, and we will share the link with you all at the earliest. Finally, we would also love to receive your feedback along with any suggestion for further improvement. Thank you very much once again. Have a nice weekend. Goodbye.
As a final thing, I think let's make a, on that meeting, the upcoming meeting, make a decision on that.
Yes.
Yeah, definitely we will make a decision and we will revert.
Yeah. Yes. That way the ball will keep rolling.
Yes. And I will try to get 1 or 2 manufacturers from outside Tamil Nadu also.
Okay.
Right. Maybe in.
So let's do it within a week or that time. Let's not wait too long because it just dilutes the.
Definitely.
If we can do it within a week, it will be great.
Yeah, we'll endeavor to do that, Doctor. Yeah. Definitely.
Otherwise, we just lose the tempo.
So now a lot of people are free right now, so it'll be easier to get them within a week. So we'll definitely.
Yeah,
really do that.
I don't fully agree that, but it's too hectic nowadays.
Yeah.
More work nowadays.
Thank you, sir.
Yeah. Okay.
Thank you very much.
Thank you, sir. Thank you, everyone.
Thank you, sir. Thank you, sir.
Thank you. Thanks, sir.
Yeah, thanks, brother.